Good afternoon to all. Okay, I hope I am audible. Can anyone confirm? So, first we will talk about recursion today. And okay, how about now? Is it better? Hopefully, I am clearly audible. I request someone to confirm if possible. Okay, thank you so much. Okay, so first we will talk about recursion, and before we kind of concretely look at into kind of problems associated with recursion and how we can take benefits out of it. Let me start with one of the most simplest example possible with respect to recursion, and then we will take formal problems with respect to coding, and then of course we will discuss solutions of them. So let's say I start with this particular question. How many hours you have spent with respect to, I should say, on practicing Python since the starting day of this particular course. Okay. So instead of asking all the cumulative hours, I can straight away ask how many hours you have spent for Python learning today. Okay. So to be precise, today is the 5th day of this particular FDP. So I am asking for this particular value. Where here FH stands for how many hours you have spent on learning Python, right? Or maybe I can give some meaningful name also. Like for example, PH of 5 stands for how many hours you have spent on day 5 of this FDP for learning Python. Okay. So now, either if you are like you can be straightforward, you can give me some number like you will say, let's say sir 1 hour or 2 hours, or someone can also say that let's say 0.5 hours or 0 hours, right? Depending upon how much time you have actually spent on this particular subject today. Okay. But now there can be some different way of answering this particular question also, and that can be, you can say the amount of hours which I have spent on learning Python today is equal to amount of time or amount of hours which I had spent yesterday. In other words, you can say PH of 5 is equal to PH of 4. Okay. And then I can apply the same definition for, so then I will ask how many hours you have spent yesterday on learning Python. So then you will say the amount of hours will be same which I had spent on the day earlier, right? On the 3rd day of this particular FDP, right? So that means if I want to find out value of 4, then you will say it's equal to value of 3, right? Value of day 3, right? And same way, right? Similarly, we can kind of continue this, right? So PH of 3 will be nothing but PH of 2, and PH of 2 will be nothing but PH of 1. But do agree that we cannot go ahead. Why? Because there is no day 0, right? We have started from day 1. So now I have to terminate this particular idea, whatever kind of questions I have started with. Now I need to give answer of it, because ultimately what you have said, that amount of hours which I have spent today is equal to amount of hours which I have spent on day 4 is equal to amount of hours which I have spent on day 3 is equal to day 2 is equal to day 1. But now this is kind of my base case or start case I should say, and I cannot go further, right? So I have to stop over here. And now you have to give me this value also, right? So how many hours you had spent on very first day, and then you will say that PH of 1 is equal to, let's say you are saying 2 hours, then answer here is 2 hours. This is how exactly recursion works. So basically, if I give generic idea of it, then what we have done currently, I have asked you value of a particular function for a particular value or for a particular argument, right? Value of a function for a particular argument or particular parameter. And then you say this is equal to whatever the answer is there for what our argument minus 1, right? So you have said amount of time you have spent on day n is equal to amount of time you have spent on day n minus 1 for learning Python, right? So this is how this particular approach works. So the core idea, as you can see over here, is that whatever problem we are focusing on, we are trying to solve that particular problem by applying the same definition again, right? So formally, whenever function calls itself, it's called recursion. So you can see I'm not changing function over here. The name and the definition of function remains as it is. But still, we can reach to the final answer. This is happening mainly because if you observe closely, then this parameter value is reducing, right? So this is very much important. If we don't reduce this value, then we will never reach to a base case. Imagine what will happen if I say f of 5 is equal to f of 6 and then f of 6 is equal to f of 7 and then we are referring to future and we don't know those values, right? So then it will never terminate, right? So the core idea is whenever function calls itself, it's called recursion. But so that means the writing function with the help of recursion will be extremely easy because we are just calling the function again, and the definition of the function is very straightforward because what will you write inside f of n? You will say just call f of n minus 1, of course with some processing, because not every time the functions will be kind of straightforward like this, but after some processing ultimately you are going to call the same function, okay? And therefore the idea of base case is very much important because if we don't have base case, then we won't get our approach won't terminate and we will never reach to the final answer, right? So the core idea is this, but things will become clear when we concretely take some examples and then talk about it more. But I am repeating one more time, it's more about whenever function calls itself, but of course usually what will happen, the parameter value or argument value will reduce so that eventually we will reach to base case. So it's so whenever any problem is given, first we need to think, can we write the solution of the problem in terms of problem itself, alright? Of course along with second idea that the parameter value must be reduced, and eventually we must also need to include the base case and then we'll get the answer, okay? So let me try to showcase this with one simple example, and then we'll go to Google Colab notebook and then you will be able to appreciate this. So I am starting with one of the most simplest one can say problem of identification of factorial, okay? So let's say we would like to find out what is the value of factorial 5, okay? F stands for factorial over here, and I want to find out a value of fact of 5, or in other words factorial of 5. Now all of us know what is the factorial 5. It's nothing but 5 times 4 times 3 times 2 times 1. But if you observe carefully, then this second part, right? 4 times 3 times 2 times 1. This is nothing but, we can say this is fact of 4. And now we can easily see that this problem can be solved using recursion, because in the solution of fact of 5, I am again using definition of fact of 5. I am calling the same function one more time with reduced argument, in this particular case 4. So in general, I can write this recursive definition. Fact of n is equal to nothing but n times fact of n minus 1. This is the first, I should say, insights which you must get by looking at the problem, whether you can write this problem in terms of problem itself with some reduced argument or not. So that's the key idea. Now let's try to understand how we will get value of fact 5. Okay, we have written that fact 5 is equal to 5 times fact 4. Let's continue this. So now you will call fact 4, and by definition fact 4 is nothing but again 4 times 3 times 2 times 1, which is, I can directly write 4, it's nothing but fact of 3. 4 times fact of 3. Now you need to call again fact of 3. How we will get value of fact of 3? It's nothing but 3 times fact of 2. Okay, and we will continue like this. Fact of 2 is nothing but it's 2 times fact of 1, and now we cannot go further, right? Because fact of 1 is the base case, and we can just say, right, fact of 1 is equal to 1. So this is the forward pass, right? So you can see we don't do any kind of work over here. We are just doing nothing but function calls. So if you focus over here, then what we did, first we called f of 5, then f of 5 called f of 4, then f of 4 called f of 3, right? So we are kind of moving ahead, right? 5 calls 4, right? So it goes like this: 5 calls 4, 4 calls 3, 3 calls 2, 2 calls 1. And this is my base case, so I know what is the value of fact of 1. Now we will backtrack, right? So now actual work will start, because so far all these functions are waiting for the answers to be obtained, and then the actual answer will come, right? So far we haven't solved anything. We are just saying for factor of 5, bring the value of factor of 4. For factor of 4, bring the value of factor of 3. For factor of 3, bring the value of factor of 2. And for ultimately factor of 2, bring the value of factor of 1. And let's say now we are giving value of factor of 1. So with this value, we are going to substitute this value. This is kind of return. We are going to return 1. So now factor of 1 is replaced with 1. And now you can see, now I have value of factor of 1. So factor of 2 was waiting for this value. And now it can compute its value, which is nothing but 2. So it will say factor of 2 is equal to 2. And this can be given over here. Right? So f of 3 was waiting for this value, which is nothing but 2. So now f factor of 3 can be computed. So we are going backwards now, as you can see. So now this is like this. So now we have got a value of factor of 3, which is nothing but 3 times 2, 6. So this value will be returned over here. So now here it's 6. 4 times 6 is 24. Factor of 4 was waiting for this 6 value, which is coming from factor of 3. So basically we will get 24, and this 24 will be given back to f of 5, which was factor of 5, which was waiting, right, since the beginning. So now this is replaced with 24, and now we'll get the final answer, which is nothing but 5 times 24, which is nothing but 120. So as you can see, a lot of function calls are happening, and finally when we reach to the base case, then only function calls will stop, and then we get kind of values which will be kind of propagated towards the top of the function call, right? So this is the core idea, and of course we have to explicitly mention about base case, then only we will get the answer. Okay, so now I will share my Colab notebook, and then you will be able to appreciate how this works. So just give me a minute. Let me just share notebook from this system. So okay, let me share my screen. So hopefully it is visible. Yes. Okay. So as you can see, it's visible. Okay. Okay. Fine. So I already talked about these 3 aspects. Let me just try to reiterate. Base case is important. It's the smallest, or one can say simplest input for which we can answer directly. And for example, in the case of factorial, it was nothing but a factor of 1 or factor of 0. That is nothing but our base case. Recursive case, this is nothing but we are just expressing the answer of current input in terms of answer of a smaller input. And then we have to talk about progress condition. Each recursive call must move closer to the base case. This is very much important. Otherwise, we will get problem of infinite loop or infinite recursion. Okay. So now things will become when first let me just go through this problem, and then we'll talk about some other problem. Okay. So let me just try to focus on this idea of factorial, and then I will pick another problem, and then we will discuss. So as you can see, it's the definition is very straightforward. We are starting with def, def, and then we are just writing the name of the function. In this particular case, it's factorial, and then I'm just passing some argument, let's say n. Right? So far I haven't given any value of n because this is definition of function, so I don't need to. So the core idea of recursion you can see over here. We are going to return n times factorial of n minus 1, but this is in all other cases except for the base case. Right? So as you can see, for base case, the termination criteria is over here. If n is equal to 1, then we are going to return 1. Otherwise, this recursive call will continue, right? So return n times factorial of n minus 1. So now it's very easy, right, to understand this. This is my recursive definition, which will go over here, and this is my base case, which will go over here, and that's it. This is my program. And now I will give some specific value of n. For example, what will happen if I give n is equal to 5? Then 5 will call 4, 4 will call 3, 3 will call 2, 2 will call 1. For 1 we will get answer first, and 2 was waiting for 1, so f of 2 will be 2 times 1, which is nothing but 2. Then f of 3 was waiting for 2, right? So value of f of 2 will be returned to f of 3, right? So f of 3 will be able to calculate its value, which is 3 times f of 2, which is nothing but 3 times 2, 6, and like that eventually we will get the value of f of 5, which is nothing but 120, right? So that's how it works, and this we have already seen that in the like conceptually I have shown this in the write-up. Now let me talk about another simpler problem so that you can appreciate this nicely. So the problem is simplest possible which you can imagine, that I would like to take or count summation of first n numbers, first n integers, and value of n can be anything, right? So what can be the recursive formulation for this particular problem? Okay, I'm repeating the problem. For example, if I give value of n is equal to 10, then what I'm asking for is sigma 10. What is the summation of first 10 integers, right? So it's n times n plus 1 divided by 2, right? So that's a formula which all of us know. But now, let's say we don't want to apply that particular formula and we would like to solve this particular problem with respect to recursion. Then can we say that if you want to find out sum of n numbers, then give me sum of n minus 1 numbers and I will just add the nth number to it and that will be my answer. So this will be the recursive definition, that if you want to find out sum of 10 numbers, then give me summation of 9 numbers and I will just add the 10th number to it and that will be my final answer, right? So this is the recursive idea, but we have to stop somewhere. When will you stop? Again, whenever value of n becomes 0, you cannot subtract anything more, right? So that at that time you will stop. So if n is equal to 0, then my base case is return 0. Because if n is equal to 0, then of course summation of 0th element is nothing but 0, right? So that is my base case. So what will happen if you call this for 5? So 5 will call 4, 4 will call 3, 3 will call 2, 2 will call 1, right? So when you call for 1, then what will happen? You are going to return 1 plus sum underscore n0, right? So value of n becomes 0 now, and for 0 we will get the base case, and then ultimately all the functions from 5, 4, 3, 2, 1, they were waiting. They will get, first f of 1 will get its value, which is nothing but 1, then f of 2 will get its value, which is nothing but 1 plus 2, which is nothing but 3, so on and so forth, and finally we will get value of f of 5, right? So that's how it works. So now if I just want to find out k in range, let's say from 6, that means I'm going to talk about 0 to 5, and then I'm just finding out sum of kind of n digits, and that n is ranging from, let's say, 0 to 5, then we can just straight away go get those numbers, as you can see, right? So this is the idea of recursion. Now let's try to visualize this in terms of what function calls happens and at what time we get some kind of return values. So let me try to kind of reiterate. I'm not changing the problem or the solution, but in between, as you can see, I have entered some print statements just to understand how this what is the flow of this particular function call, because this is not normal function call. In normal function call, what happens? You just call this particular function, it will call just once and we will get what we want. But here the same function will be called repeatedly, right? And we just want to analyze that how it's working. So let me just try to showcase that. Okay. Just a second. So as you can see here, the first comment is, as you can see, this is my comment: sum of first and natural integers with tracing of calls. So that means we are just trying to understand how this function calls works. And as you can see, okay, so the better idea will be that let me just call this particular function and let's focus on the output first, how it looks, and then I will showcase that why that is happening. So maybe I can just go to slideshow so that you can appreciate this. So this is my function, but more interesting part is right, it's output, right? So let me try to run this, and if I can showcase, okay, yeah. So I can, as you can see, so whenever you call 4, you know what is the base case. Base case is 0. So it's going to 4 will call nothing but 3. So as you can see, first call is for 4, then call is for 3, then call is for 2, then call is for 1, and 1 will also call for 0. So all of these are function call. So far we haven't done anything. All these functions are waiting. It's called stack formally, right? A stack of functions which are waiting. So, and on the top of the stack, so that means the last function which is waiting is nothing but with function called 0, right? So as you can see, the last function will get its value very first. So as you can see, exit will happen with respect to the very last call, which is for f of 0. So now it's going to return value 0. Now 1 was waiting for this 0. So 1 plus 0 will be returned by this call. So as you can see, exit with returning value 1. Okay. Next, 2 was waiting, right? And 2 was waiting for value of f of 1. So 2 plus 1 is nothing but 3. So that particular return is happening right now. Then next iteration, 3 was waiting with 2. So 3 plus whatever is returned by 2, which is nothing but 3. So 3 plus 3 is 6. That is obtained over here, and now work of f of 3 has been completed. And f of 4 was waiting for f of 3. So f of 3 has given value 6, and f of 4 will give value 4 plus whatever is given by f of 3, which is nothing but 6. So finally we are going to get answer 10. Okay, so this is how it works. Any questions up to this point? I will wait for 1 minute in case if you have any questions with respect to recursion. I am showcasing both the codes one more time in the simplest format without any further comments. Yes, I am going to share the codes for sure. I will share the entire notebook, don't worry, right? So that you can try side by side. If you want, I can share right away. Okay, so just give me a minute. Sure. Let me share my entire notebook with you so that you can kind of practice with me, right? And so what I will do, I will just create its thing. But what I recommend you to do is you create a copy of this notebook and then play with it. Otherwise, your friends won't be able to get it in the original, one should say, version, because if you edit this simultaneously, then it will be disturbed. So I am sharing it straight away, but what I recommend, you create copy of it and then do your changes, right? So let me just, okay, not viewer, let me just share it with editor, right, so that you get full access to this. Okay, so you can take 1 minute just to access this and copy, and then we'll continue. Meanwhile, if you have any questions, then you can just write in the chat box. Just a second, I guess the mics are on from two. आप वहाँ से mute कर सकते हो? Yes. All right, so I guess you got enough time, and hopefully you have kind of opened this and created a copy so that you can try this simultaneously. Okay, in case of any queries, again I request you can just write in the chat box. Okay, so let me continue. Hopefully yes, my screen is visible. Okay, so now, okay, so this is with you. Okay, let me continue over here. So this was about kind of simplest possible example that where we have talked about how to take summation of n numbers, how to compute summation of n numbers using recursion. Now let me take one more kind of famous problem, which is called Fibonacci sequence. So what is the idea of Fibonacci sequence, right? So it's a very, okay, so maybe I can just quickly write over here. Okay, so now let me talk about Fibonacci sequence. It's very intuitive. So the idea is this. Let's say these are some initial numbers 0, 1, 1, and now what you are going to do, the next number which you are going to generate, it will be summation of previous two numbers, right? So you are going to add the previous two numbers and get the next numbers, right? So previous two numbers are in this particular case 1 and 1, so we'll get 2. Okay, and we'll apply the same definition again, right? So you can see recursion over here, that every time we are repeating the same function, you are generating new values based on previous two values, right? So what will happen? The next value will be 3, the next value will be 5, right? So on and so forth, right? 8, right? Right? And then 13, right? So this is called Fibonacci sequence. A lot of applications are there. You can just go to ChatGPT or Gemini or even Google and you will understand, right, what are the applications of this Fibonacci sequence. But our focus is on recursion, therefore I'm not going into those interesting aspects about this Fibonacci sequence. But in some sense it's associated with beauty, nature's beauty, right? And there is some ratio which is associated with this particular sequence, which is called golden ratio, right? And fine, so that much information is sufficient as of now. Now, if we talk in terms of recursion, then what I would like to know is, I want to find out, let's say, nth number of Fibonacci sequence. Then this recursive definition will tell me that if you want to find out nth number, then just first find out n minus 1th number, and then find out n minus 2th number, and then just add these two numbers and you will get the answer. But now something is different over here as compared to our original problem of factorial. If you notice carefully, in the case of factorial, and the difference is not in terms of recursive definition, of course it is, in some sense it's there, but the core idea which I am going to convey, it will be applicable mainly to base case. So if you notice carefully, in terms of recursive definition, the idea is similar, that instead of n it's becoming n minus 1 and n minus 2. This is fine. But if you observe carefully, the number of terms are 2. Right? So that means whatever solution which you are going to propose, that will be dependent upon two values. So now you will be able to easily kind of map this with the base case. What will happen to the base case? If you have just one base case, let's say my base case is, let's say, 0th element of this sequence, right? I am going to say 0th element. If value of n is equal to 0, then I am going to return, let's say, 0. So this base case alone won't be sufficient. Why? Because whatever function you are calling, let's say I am waiting for, let's say, fib of 5, then fib of 5 will be waiting for two different answers, fib of 4 as well as fib of 3. Then only it will get the final solution, right? And similarly, this will, so if I completely kind of draw this particular branching, then you will be able to appreciate even more. So let's say I want to find out fib of 5. Fib of 5 will give me fib of 4 and fib of 3, then only I will give answer. And fib of 4 will say, give me fib of 3 as well as fib of 2, then only I will give the answer, right? So likewise it will continue, fib of 3, fib of, in this particular case, 2, 3 and 2, these two terms are previous terms. Over here it's 2 as well as 1, okay? And now we can go one step even ahead. Let's say 3 is waiting for, again, fib of 2 as well as fib of 1. And this 2 is waiting for fib of 1 and fib of 0, okay? And here we can go one more step, fib of 1 and fib of 0. And 1 we can't go ahead, right? Because for 1 it will be 0 and minus 1, and there cannot be minus 1 element in the sequence. Sequence will start from 0, that is our assumption. So I have to give mandatorily value of fib of 1, that is obvious. But if you notice carefully, then this value alone is not sufficient to calculate anything else, because we will be needing value of fib of 3, and fib of 3 depends upon fib of 2, and fib of 2 again depends upon fib of 1 as well as 0. So even if I give this particular value, let's say first value is 1, if I give this two values, let's say here the answer is 1, here the answer is 1, then and here also answer is 1, and here also answer is 1. So if I highlight those which I have already given kind of answers, then also this kind of our answer, we won't be able to reach to the answer. As you can see, this is only solving the half of the problem, the highlighted part. The next part is still pending, right? So that means it's very obvious that we have to give two base cases, then only we will be able to solve this particular problem. So along with fib of 1, we must give value of fib of 0 also, then only we will get to the final answer. So if I give, let's say f of 0 is equal to 0, then from this 2 we will be able to get value of fib of 2, right? And fib of 1 is anyway there, so we will be able to find out fib of 3, right? Similarly, the same branch is over here, fib of 3, fib of 3, that's so correspondingly t will be the same, right? So I am not repeating it to save time. So if this is solved, then this is also solved because these are identical. And now These two are also identical, fib of 2, fib of 2, and I have already given this answers, right? This is also now my base case. So if I give this answer, then we'll be able to get answer for fib of 2, fib of 2 also. Then from fib of 2, fib of 1, we'll get fib of 3. From this 2, we'll get fib of 4, and from this 2, finally we'll get fib of 5. Ultimately, like, we'll be able to get everything. But the key idea was from the definition itself. So it's always a good idea whenever this kind of problem comes, you should take pen and paper and think about what will happen if you try to solve this for some very small values, like for example 5 or 4, and then you will kind of get intuition what should be your base case, right? So hopefully you understand why two base cases are required for this particular problem and why one base case is not sufficient. And this tree which I have drawn, it showcases the limitation of this particular method also, right? So as you can see, in every call you are calling two more functions, so it's growing exponentially. So you can imagine if I give value very high, let's say k is very high, k is let's say 100, then roughly you are going to call 2 raised to 100 functions, right? So it's a very big number, right? So therefore not every time like recursive solutions are kind of appreciated, because it will do a lot of work. And not only that, if you notice carefully, if I redraw this particular tree one more time, then you will appreciate and you will be able to identify the different issue associated with this particular one can say problem solving mechanism, and that is nothing but, I should say, the overlapping subproblem. So there are two terms in this, overlapping and subproblem. What is subproblem? Subpart of problem, just like subset, right? Something which is not full, right? We are just considering portion of our problem or portion of our set. If portion of set, then we will say subset. Portion of problem, then we will say subproblem, right? So now I will explain the term overlapping very soon. But if we talk about f of 3, f of 4, f of 2, all of these are called nothing but sub-problems of the problem. And the issue will come over here. Let me just, okay, so I am not completing the tree now. Okay, I should, I guess, then you will appreciate it even more. So let me just complete this particular tree very quickly. This is 1, this is 0. So those are my base case, so I should not go further. This is same, like 1, 0. So this is fine. And here 1 is my base case, so I should not go further. And here again 2, for 2 I should go for 1 and 0. And here again this is my base case, so I should not go ahead. Now if I circle some nodes, then you will be able to appreciate the meaning of this overlapping subproblem. So if you see that, okay, so let me circle, not erase. Okay, so let me use different color. Okay, fine. So if you focus over here, f of 3, so what is the purpose of this branch? It's trying to, what is the purpose of this branch means, what is the purpose of this f of 3? F of 3 is a function call which is trying to compute what is the value of third element of this particular sequence, right? So all this remaining elements, they are just supporting this particular task. And now if you notice carefully, then again over here we are having the same f of 3, and here also we are going, the same kind of work is going to happen over here. If you notice carefully, then even the corresponding function calls are same, right? Because effectively the problem is the same. So this is called overlapping subproblem problem. That as you can see, we are doing repeated work, right? And that too many times. We could easily do this once and store it somewhere. That's what exactly dynamic programming does. But in the simplest form, recursion, these are the issues that you are kind of doing extra work, right? And which is not good, right? But still, in terms of definition, it's very clear, and for reasonably large number, you can go ahead with this particular method. So now let me again go back to our code, and then you will be able to appreciate this even more. So, okay, fine. So now my screen is visible, and now you will be able to appreciate this particular code also. If k is equal to 0 or k is equal to 1, then we are going to return k. That means if zeroth element of this particular sequence is nothing but right? Zeroth element is 0, first element is 1. So therefore we are just returning like this. K is equal to 0, then we are say 0. K is equal to 1, then we are going to return 1. Otherwise we will just say it's recursion k minus 1 plus k minus 2. So in terms of writing, it's not a rocket science. You can easily do it, right? It's very straightforward. You just need to identify the recursive definition and the base case. That's it, and then call it for whatever value you want. For example, I want to find out 8 value of this particular sequence, and that is nothing but 21, and we can easily get it. And you can also verify the correctness of it, and it's correct anyway. Fine. So now let me go ahead and kind of showcase you some other aspects of this particular recursion. So we have already seen this Fibonacci, okay, and now we will talk about some more applications. So hopefully you have learned about this Python data structures. Do you know about list, Python list? Anyone? You can just write it down in the comment whether you know about it or not. It's okay if you, even if you don't know, you will be able to appreciate it very easily. But I just want to know whether you know it. So accordingly, I will kind of explain this. Anyone? Do you know about Python list? Yes. Okay. Fine. Thank you. So now, as you can see, let's go to this particular problem, and then you will be able to appreciate it, how it works, okay? And what are the benefits, of course. So what is our problem? As you can see, first let's see the solution so that you understand what we are doing actually, and then we'll look at into the code. So as you can see, some list is given to us 3, 5, 2, 0, and the problem is similar. We would like to find out summation of all these numbers which are present in the list, and we can verify that if we call the inbuilt function, there is one inbuilt function which is called sum, and we can just pass this particular list, and we get answer which is 20, and the same answer can be also obtained with the help of recursion. So how recursion works, let's try to understand in the context of Python data structure, right? So that is the motivation. So as you can see, this is my definition, sum underscore list. This is my name of the function. I'm going to pass some list, so that is the first argument, and then I'm going to say the index value. I'm saying it's going to 0. So this is very much important. If I'm starting from 0, then I will end at something bigger, alright, and that should be my stopping criteria. If I'm starting from some big value, then I should stop at some very small value, right? So hopefully you understand this. So base case and depends upon, right, from where we are starting. So here I am starting from smallest possible value of index, which is nothing but 0. So I must stop at largest possible value of index, which is nothing but length of array. So which is obvious, as you can see, whenever you reach to this particular length of array, I becomes length of array. At that time you will stop, right? Fine. And otherwise, what you are going to do, you will just say, right? For example, first in the very first iteration, what will happen? You are going to call this for ARR of 0. Yes, so because value of I is in this particular case, let's say we are going to call this for this particular list, right? Okay, and then we are saying that ARR of 0 plus sum underscore list. We are going to pass the same array again, but this time the index value will start from 1, not from 0. So basically, what this does is it's similar to summation of first and integers, right? Here we are just taking out 3, and we'll say sum is nothing but 3 plus whatever this sublist does, right? Whatever the summation of this sublist is, right? So 3 plus sublist of array, and index value will start from 1 now, right? So whenever index value will reach to this particular value, in this particular case length of array, at that time we will stop. So can anyone tell me what will be the last call associated with this particular data list? In this particular case, we are starting from the very first call, which is corresponding to 3520, and then 3 will be separated out, and then we will call for 5 to 10, right? So the corresponding, you must focus over here, how you will reach to the base case. First you will call this for this list, and the second time you will call it for this list. In this and index is starting from 0, right? So core idea is index is starting from 0. So when you reach to the very last position, at that time the index value is 3, and you are going to say 10 plus sum underscore list, same array, but index value is 4. And now we will reach to the base case because our index value is 4, length of array is also 4, so we will stop, and that's how the base case is achieved, right? So hopefully you appreciate it and you understand it, how we will reach to the base case. I am repeating one more time. When you separate this out at the very last time when this function calls happen, it will be happened for index value I is equal to 3, right? I is equal to 3, we will do this call, and we will call this particular function with the same array, but the index value is 4 now, because I plus 1, 3 plus 1 is 4, and 4 is corresponding to this base case, right? Because 4 is equal to length of array, then we will return 0, because now list is empty, right, in some sense, and then the value will be returned, which is nothing but 0 in this particular case, and then we get summation, like 10, and then it will be 2 plus 10, 12, then 17, and then finally 20. Right? So that's how we can apply recursion to list. Right? So as you can see, same idea we can also apply, not I should say exactly same, but similar idea you can also apply to identify maximum out of the list, right? And again, you can revisit this. You already have this notebook, so you can just go to this, that you can find out maximum via recursion also. You can find out maximum with the help of this inbuilt function also. In both the cases, you will get, of course, the same answer, right? And the idea is again very much similar, right? So hopefully you will get it. Okay, fine. Now let's go to the next part, which is again very much interesting idea, and in computer science as well as in normal, one should say, various applications related to data, we often require kind of optimized search mechanism, right? So for example, let's say I would like to find out, let's say we can take simplest example of let's say marks of our students, and I would like to find out what is median of the score, right? This kind of application we can think of. Or I would like to find out what is the marks of the in some sense, let's say I have 100 students in my class, and I would like to find out, usually we talk about only top 10, but I would like to find out what is the marks on 15th position, right? So so that means I'm looking for a very specific location out of this all possible kind of elements, and we are assuming that elements are already in sorted manner, and then I would quickly like to find out a particular location, right? And as a faculty members, we have applied this many times. For example, let's say all the student marks have been sorted in terms of ID numbers, and let's say you have 100 different. Okay, so maybe what I can do, I can just share my screen of this device, and then you will be able to appreciate this. So, okay, so the problem which we are going to take is, let's say we have answer sheets with us, and answer sheet contains around 100 students and marks of 100 students, and those answer sheets are sorted, right? Sorted based on let's say ID numbers. Okay. And let's assume that ID numbers are going from like this: ID 1, ID 2, ID 3, ID 4 up to ID 100. Okay. And for each answer sheet, of course, we are interested in marks of them. Okay, so we have marks, right, associated with each ID. Right? Let's assume that our students are performing very nice, and these are the scores out of 100. Okay, so like this it is filled. Okay. Okay. So now let's say the task is you need to find out answer sheet of student ID. Let's say 27. What will be your approach? So if it is 100, then it's very easy. But let's assume we have 1000 answer sheets like this. Okay. So the ideal approach is you will, and it can be any number, right? It's not like that 27, right? It can be 127 also, right? For example, let's say 127. Okay. So usually what we'll do, right? It's a pile of this kind of answer sheet. We'll kind of look at into middle, right? So what will happen if I look at into the middle? If number is like kind of 500, then I know that the remaining 500 are kind of meaningless for me, because my answer sheet is not there for sure, because I'm looking for some number which is of course less than this 500. So I must look at into the first half which I have picked. Okay, and then I can repeat the same idea over here. So you can see how recursion comes. The strategy which I have applied initially, the same strategy I am going to apply for the rest of the problem. So again, if you go step by step, then for any recursive problem, the first idea is your solution space must be reduced, right? So if you recall, in the case of factorial, what is happening? It is reduced by 1. In the case of Fibonacci numbers, also it's reducing. Here also what we are doing, this is extremely good because we are reducing it by factor of 2. Initially, we were searching one answer sheet out of 1000 answer sheets. Now, just after one iteration, just by checking the middle answer sheet, we know that the rest of the pile is not associated with us. So we have eliminated half of the solution space in some sense. So now, what's the recursive idea over here then? Whatever pile I have, I will divide it into two parts. I will try to divide it exactly of same, I should say, height, so that I can reach to the middle element, and then I will look at into the middle element. if middle element value is greater than what I am looking for, then I will ignore the rest of the part associated with that particular partition. So for example, if I repeat this one more time over here, I have index value from 1 to 500 and I am looking for 127. So what I will do, I will look for the middle value, middle ID number. Middle ID number is 250. So my ID number is less than this 250. So I will ignore this part. Right? So in every iteration, as you can see, my solution space is reducing by factor of 2. Right? My problem space, which I was searching, initially I was searching for out of 1000 kind of answer sheets. Now I am searching just 250. Right? And now I will repeat one more time. So now what will happen? In middle, I will again search for 125. So this time I will ignore this one. So I have only 125 answer sheets with me. And again, this is like this. Only this file is remaining with me. I can repeat this one more time, the same process. Right? And again, we are not adding any kind of extra knowledge of our mind in this particular process. Otherwise, you can just say that now in this sheet, I just need to remove the first two and I will get the answer. But that extra knowledge is with you, but not with computer system, because we are going to code this, right? And number can be anything. It can be any number, not necessarily that it will always close to this kind of boundary, right? My number can be, which I am looking for, it can be 200. In that particular case, of course, I have to have some kind of mechanism to reach to that, right? So in this particular case, coincidentally, the number is close to this boundary, so you can think of those kind of shortcuts, but in general, right, the shortcuts may not work, right? Fine. So now, what will happen in the next iteration? I will do this kind of thing. 125 plus 250 divided by 2. This is kind of, I am trying to find out what is the middle element of this 2, right? So this is the kind of 375 divided by 2, and then I can take ceiling or floor of this, right? Because the number is odd, so I may not get the exact answer. So maybe I will reach to this kind of number, right? So 18 times 2 is 36, and then 15. So basically, right? It's I should say 7, right? And then I can take, let's say, 180. Okay. So now again I will repeat the same idea. Let's say middle element is kind of this 188, right? And now again I will search that my which I am looking for, this number is not in this side, because I am looking for 127 and 127 is less than 188. So I will ignore this part, and then I will repeat this particular process for this like whatever is remaining now, right? 127 to 188 and 125 to 188, and then I will do this couple of more times and finally reach to the final answer, right? So this is called nothing but binary search, right? So hopefully you understand what will happen, and if you want, I can again take one smaller example so that we can quickly see how it works. So maybe I can quickly take one small example where elements are only we can take roughly, let's say, only 16 elements are there, and let's say 1 to 16, and I am looking for a particular element which is at location 4. Okay. So now how this particular process will work? Initially you will find out the middle element, let's say at 8, and since 4 is less than 8, I can just ignore this first part in the first iteration, that my solution does not fall over here, and now I can find out middle element over here. So this time middle itself is kind of 4, so I will check 4 is equal to 4, so I got it, right? So that's how it works, right? So either whatever you are looking, either it's the middle element, or it's left hand side of the middle element, or it's right hand side of the middle. So wherever the element is, we'll just keep that particular portion and we will ignore the second portion, right? So that's how binary search works, and you can get the idea that after how many iterations it's ensured that we will get the solution. So initially I am starting with n points. After each iteration I am dividing my kind of problem space by factor of 2. So let's assume after I iteration I have got just one element. So that means after I iteration I cannot go ahead, because if I have just one element, then how will I apply the process? I must need at least 2 elements to kind of find out the middle element in some sense. Okay. So if one element, single element is remained, then I cannot go further with respect to this particular process, right? So I need to just find out when this happens. So I need to find out a particular value of I such that n divided by 2 raised to I becomes 1, right? So I can just say n is equal to 2 raised to I, and then I can take log both the sides, then I will get I is log n. So that means after log n iteration, I will get my answer, right? So, but there can be some scenario that, for example, I am looking for a particular ID which is not present in the list. So in that particular case, the process will terminate and we couldn't find that particular number. But if number is present, then this process will kind of ensure that we get it after log n iteration. And it's a very fast process. As you can imagine, what will happen? What will the value of log 1024? Right? This is kind of 1000 of computer science. So this is equal to I can say log 2 raised to 10, which is nothing but 10. So just after 10 iteration, I can find out any element out of this big list of length 1024. But what will happen if you just check one by one? It will take 1024 comparisons for sure. But of course, there is one drawback of this system. We are assuming that all the elements are sorted. Then we can apply this, right? So that's the limitation. And now we can talk about the code of this particular interesting algorithm, which is called binary search. And this is first example of, one can say, divide and conquer technique also, because we have divided our problem into sub-problem, and now we are just solving the sub-problem recursively. Okay? So that's the idea. And you can also look for interesting algorithms, like you can go ahead and look for algorithms like merge sort, quick sort, all these famous algorithms, and they are in terms of efforts, they are the best one for the comparison based sorting. All of them are recursion based, right? Okay, fine. Anyways, so if you talk about this binary search, now hopefully you get the idea. This is my array or list. This is the value which I am searching for. This is kind of index value. What's the starting point of my array? What's the ending point of my array? Right. So this is the idea of recursion. And as you can see, we are going to find out the mid element. If mid element is the target element, then we are done. We don't need to do anything. If target is less than mid element, then we will search in the left side. If target is so if this is false, then of course target is greater than mid element. So then we will search in the right side. So as you can see, accordingly we are setting this up. That if my target is appearing in the left side, then I will starting from left, but my ending point is mid minus 1 now. It's not right, if you can see. Right? Initially I am starting from right, but now I am saying we will go all the way up to mid minus 1. Why not mid? Because element is not mid. Then only we have reached to this particular point. Right? Now the next one is, as you can imagine, what will happen over here? My element is greater than mid, so I must start from mid plus 1, and I will go all the way up to the right hand side. Right? So that's how it works. Okay? So hopefully you will understand this from this particular demo. Let's say elements are like this. First, we will sort this element, right? So in this particular case, I have already taken sorted. 2, 4, 6, 8, 10, 12, 14, they are already sorted. And now we are kind of going to apply. These are my target values, right? 2, 7, 14, 3. I am trying to find out these values in my this particular sorted list. So first one is 2. So 2 is found at index 0, which is correct. Second value which I am searching is 7. So 7 is found at index minus 1, because as you can see, there is no 7 over here, right? There is no 7. Okay, so if something is missing, then we are going to return minus 1. Okay, so that means the element is not present, right? So then we'll say it's minus 1. So in the case of 7, and this will happen precisely when left is greater than right, which is not possible, because now your left must be, of course, if your pile length is greater than 0, then of course your left must be kind of less than right, right? So if this case is happening, that means it's not correct, element is not present. Okay? So that's how it works. Okay? And this will happen in the case when you couldn't find element, right? Otherwise, if element is found, then we are going to return it, right? That will happen eventually, because we are trying to narrow down this kind of problem space, and eventually problem space will become solution space if element is present eventually. But if that doesn't happen, then we'll reach to this kind of base case, and then we'll terminate with minus 1. Right? And otherwise, with respect to 14, we'll say it's index 6. For 3, again it's not present, so we'll return minus 1. Right? And you can actually take some values, then you will appreciate it even more. But I am just giving you the core idea of this interesting binary search algorithm, right? And it combines idea of all these things, right? As you can see, first we are talking about sub-problem, and intelligently we are kind of removing the sub-problem which is not required in every iteration, and fantastically we are reducing the problem size by factor of 2 after every iteration, and finally we got the answer. And very nice example of binary search, as you can see. Again, I should say very nice example of recursion, as you can see. That every time I am calling the same function, same binary search has been called over here as well as over here, but with different parameters. Okay, fine. So that's what recursion is, right? And one other kind of application with respect to recursion is enumeration, right? So you can guess how it works. Like if I want to generate that kind of all subsets of a given list, then I can apply recursion because ultimately there are two. It's kind of inclusion exclusion. I could consider all solutions which includes this particular element I, and then I can consider all solutions which exclude this particular element I, and then I can just combine these two. So that's how it works, right? And we'll take the kind of same approach, recursive approach, when we try to generate this kind of list. Okay. So as you can see, what I'm trying to do is, in this particular case, I have this 3 elements, and I'm trying to generate all possible subsets. So we know, right, from basic mathematics that 3 elements are given, then we are going to get 8 different subsets. And as you can see, all those 8 subsets have been generated. Nothing fancy over here, but we will see how recursion is used over here. Okay. So as you can see, the original function is generate subsets, and you can see we are calling the same function again and again. And in this particular case, we are going to excluding the element, right? So as you can see, my index +1 I am starting, and then I am including. Then I am continuing with the problem. So that means I have ignored the element which is present at index. So that means it will create all the subsets without the first element, right? When we call this for the very first time. And this choice 2 is we have included that particular element. Append means we are going to include that particular element in our answer, and then we are going to again call the same function. So that means this is my choice 2. Combine, if I consider the highlighted part, then what I am going to do, I am going to consider element first. Mandatorily it will be present in all the subsets which I am going to generate now, right? So, and both of these are kind of I should say disjoint, right? The choice 1 and choice 2, right? Because in choice 1 element 1 is missing, and in choice 2 the element 1 is included. So that means in terms of counting they are disjoint, right? There is no repetition, right? Okay. So this is the core idea of this generate subsets method, right? So this is one more interesting way how recursion works. But of course every method comes with limitation. I have already explained one limitation which can be kind of avoided with the help of dynamic programming, right? So another fantastic mechanism using which we can kind of eliminate the issue of overlapping subproblem. But let me just try to highlight some other issues which are practically there when we try to implement recursions in the case of Google Colab or any other kind of IDs. Okay. So let me just try to showcase this. So as you can see, this particular code, I have just imported one library SYS, and then I'm just trying to find out what is the limit with respect to Python if we try to implement recursion. So it says 1000, right? So in some sense around 1000 function calls can be supported by Python when we try to implement recursion. Okay? And that means sometimes we may get some kind of error when we try to implement this recursion. So for example, this is just to demonstrate you that how this can happen. Let's say I am just creating one simple recursion function which just to demonstrate this issue, and we will just focus on simple recursion. For example, here whatever depth is given, for example my depth is 2500, I am going to call this for 2500. So that means, and how many function calls will be there? Can you write in the chat box? If I am calling this particular function, let me try to zoom this so that you can focus. Let's say this is my function, it's called simple underscore recursion, and there is only one parameter which is nothing but depth, and I am calling this for, let's say, 2500. Can anyone tell me how many recursive calls will be done in this particular case? You can just write it down in the chat box. Yeah, 2499. Because when we reach to the base case, well, base case is at 0. So can we say 2500 or 2499 is the correct answer? You will call for 2500. You will also call for 1. Do you agree? When you call for 1, you will call for 0, and for 0, you will terminate. So, can I say 2500 function calls? First call is for 2500, last call is for 1. In between, we are going to get 2500 different numbers. So, exact answer is 2500. Okay. So, this is, do you agree? This number is greater than the limit which we have got over here. Default recursion limit in this Python runtime is 1000. So it can support only 1000 function calls. And now what I am trying to do over here, I am calling this for 2500, then it should give me an error. Let's try to execute this. So as you can see, I am getting this error. What it is telling me, that maximum recursion depth exceeded, right? So it's too much for the system to call 2500 different functions, and all of them will be waiting to get answer. Do you understand the issue over here? That we are not completing any of the function calls. All these function calls are happening recursively. So in the memory, there will be 2500 different copies of the same function are kind of generated. So it will store a lot of, it will take a lot of storage, and therefore system won't allow this much kind of bandwidth. Right? So limitation is, you can of course with respect to your whatever ID is there, you can just copy paste this over there and just find it out. Right? You can just copy paste whatever I have mentioned in on this particular cell number 17, and then you will get what is the limitation in terms of recursive calls in your system or your ID. Fine. So now what are the common mistakes? As you can see, missing base case. This is the most important thing which you should avoid whenever you think about recursion. Ensure that you have identified the base case correctly, and depending upon from where you are starting, it may be towards the beginning or maybe towards the end, and you ensure that you write about it. Of course, base case must be correct, not just you must add base case, but the correct base case is essential. Third thing is also very much important, that it's not just about mentioning about base case. You have to ensure that you ultimately reach towards the base case. Otherwise, what's the use of it? Just like we later on you will also learn about classes. You create one class, Python class, but you don't create an object, or maybe just functions. Let's say you have defined one function, but you are not calling it. Then what's the use of that function, right? So that means it's not just about base case. You have to ensure that eventually you reach to that particular base case by recursive calls. Okay. Okay, fine. So, and of course, sometimes you do extra work outside the recursion without understanding the flow, because in between, maybe intermediate answers are also helpful to you, right? And many times you can do this kind of debugging in order to avoid kind of failures or issues. So the first one I have already recommended to you, that it's always good to start with something small, consider smaller sub-problem, and then with pen and paper try to compare what will happen with this input in the context of recursion, and then try to convert those insights in terms of code, right? So that's what combinedly that's what is suggested in point number 2 and 3. And sometimes it's also very much kind of helpful if you just put some print statement before entering and before exiting a particular function, so that you can understand what intermediate values you are getting. Okay, so these are the things which I wanted to convey with respect to recursion. I will just wait for 1 minute in case of any questions you can ask. You can just write it down in the chat box in case if you have any questions. Otherwise, we'll go ahead with the second topic. We'll primarily talk about file handling now. That is also very much important topic. I will just wait for 1 minute. Can you suggest a few use cases for practice? Of course. So what I will do after completion of today's talk, I will share I guess at least 3 to 4 problems which you can try using recursion. But now, of course, so you should do at least 4 to 5 problems by yourself. That is the first thing. But the core aspect is extremely important, because now in the era of generative AI, we get kind of code very easily. But it's important to understand what we are writing and why we are writing, right? So those reasoning will be appreciated even more. For very large numbers, like we trust the system. Like if you were, so therefore the whatever instructions we are writing, if those instructions are logical, for example, we have mathematical proofs for our recursive definition, and we have mathematical proof that along with our recursive definition and base case, whatever answer we are going to get, that is correct, right? So you can apply some kind of proof techniques, including induction, to verify that this equation is correct, right? Whatever we have derived for our recursive formulation. So, and coding is nothing but it's a language to convey computer that just follow this particular theorem or this particular equation. So then again, we don't need to verify it again with respect to very large numbers. We trust the systems that whatever registers are there or logical unit, arithmetic and logical unit is there in the our CPU or GPU, they are performing computations correctly, right? So we don't need to verify those things in terms of correctness. But of course, what we are writing in terms of instructions, in terms of for this particular lecture, I should say recursion, recursive definition of functions, those things you must verify that whether they are correct or not. If those things are correct, then ultimately our answers will be correct for sure. It's like if theorem is correct, then you can apply that particular theorem for any of the, one should say, instance of that particular problem, right? You don't need to, for example, we have proved for sigma n is equal to n into n plus 1 divided by 2, right? So now I don't need to verify it for 1 million because I have proved it by induction that y sigma n is equal to n into n plus 1 divided by 2. What I need to verify it that whenever I kind of implement this, I put it correctly inside the code. Right? So that part is important. That I don't kind of play with the actual correct fact or theorem statement, and I put it in terms of I should say syntax is correct, and in terms of instructions, our kind of whatever we are putting, it's aligned with the corresponding theorems and mathematical equations. In fact, the reverse thing is happening, right? For very large, since you have mentioned about this, in graph theory, right? If you search internet, then there are many problems, including graph coloring problem, where kind of it's very much difficult to do things via hand. And there are some special cases associated with graph coloring. Those are solved with the help of kind of computers. And that was the first example of kind of computers being used to prove some kind of theorem, right? So actually the reverse thing is happening, that we are using for some specific set of problems. We have used, there are some evidence in the history that even in the domain which is called quite theoretical, like theoretical computer science, graph theory, we are using computers to for in some sense completion of the proofs. So we trust the systems, in summary we are saying, provided our instructions are correct. And I'm talking about this Python code, I'm not talking about generative AI like ChatGPT or Gemini, right? They are entirely different systems, right? So they are stochastic based, probability based. So they can provide a hallucination. Hallucination is whatever they are giving, we can't trust it, right? But in this particular case, in terms of coding, right, it's 100% kind of what you can say. If instructions are correct, then whatever output is going to that, it's correct for sure. But of course, you have to understand some limitations. Like for example, we have seen over here that there is a limitation in terms of depth of recursion. I hope I have answered your question. Any other questions? I will just wait for 1 more minute and then we will jump to file handling. So maybe I can close this files. Okay, maybe I can focus over here. Okay. So I will wait for just 1 minute and then we will continue. Okay, fine. So no other questions. So let's start with file handling. Again, so now what is the motivation for file handling? Now, why do we need file handling? Because now somewhere in terms of FDP we are in the middle, right? And soon you will be learning about deep learning and machine learning, how we can utilize those things along with our existing knowledge of Python, right? Because once you know this kind of, so far it may seem that how and where these things will be relevant. but soon after hopefully couple of sessions you will be able to appreciate that how these things will become handy when you kind of design some kind of models in machine learning or deep learning. But whenever we use this kind of models like machine learning or deep learning models, we require a lot of data, and we are going to kind of consider two different phases. First phase is called training of based on this data, and the second phase is called testing. And how well we are going to do in terms of test, that's all matter. For example, if we talk about our students, we teach them for 6 months, and then we take this semester exam. But mainly they are going to be evaluated based on how they perform in the end term or midterm exams. We don't kind of give too much importance to how they do in terms of problems which you give them in the classroom, right? Similarly, with respect to these systems also, how well they are going to do with respect to test data, that's all matter. But for whatever kind of data is there, that data will be stored somewhere, right? Either the data can be in terms of Excel file or CSV file or normal text file, or maybe they are images. But we need to have some kind of mechanism using which we can access this kind of data files. So that's the motivation of this particular unit, that how we can utilize functionality of Python, right, in order to kind of read data from files. And not only reading is sufficient, sometimes we also need to modify these files. So therefore both are important, right? The reading means there are some existing files of data, we would like to read them, we would like to process them. For example, I can give you one file which contains marks of my students, and then I tell you write a Python program to find out average of this, or maybe median of this, or maybe who has scored maximum marks. Then you may struggle. You can say, I can do this if you give me data in terms of normal email, and then I will kind of copy paste the data, and so, but that is not efficient, right? What will you do if data contains, let's say, 20,000 students? Then you will struggle, right? So therefore we need to understand how we can directly kind of play with this kind of files which may contain kind of huge data. And 20,000 is not a big number in the context of deep learning or machine learning, because we need a lot of data when we try to create some kind of models which can understand the insights of the problem and then eventually solve them, right? So therefore we need a lot of data. Data is stored in files, and we would like to understand how to deal with those files. So that's the motivation of this. Okay. So now what I'm going to do with respect to Google Colab. So as you can see, let me try to zoom this out. You can see this particular folder icon over here, right? So let me just reconnect first, and I'm going to press on this particular folder icon. So whatever files which are associated with this kind of notebook, you will be able to see over here. So far I cannot see any file because I haven't created any. So now let me start with the very first and kind of very easy method, which is called create a new file. Okay. So what I'm going to do, I'm going to open a particular file. The name of the file is first.txt, and I'm opening it in X mode, right? So X is corresponding to create, and as you can read over here, if file is already existing, then this particular command will give nothing but error, but otherwise it will be executed, and we will be able to soon see one file inside that particular folder. So I'm repeating one more time. It's very easy. What I'm doing, I'm creating one file, and just like variable, I have given name to this particular file f, and actual name of that particular file. So in order to access purpose within this particular notebook, I am going to call it f. But inside the folder, that's just like variable. Inside the folder, the name of the file is first.txt. Okay, and I'm just giving this particular x option. So I will just run this. Let me just run this, and it has successfully completed its execution. Now let me go back and showcase you that first.txt exists over here. Can you see first.txt? And if I double click on it, then I will be able to see. I will be able to kind of modify it. Right? I can write something over here if I want to. Right? For example, let me just write it down. Hello, right? How are you? Right? Hopefully, right, you are enjoying this session on, let's say, Python programming, whatever, some text I have written, that's it. Okay. And then you can see some star over here, that means it's modified. Let me just close this. If I open it one more time, then you will be able to see the same text over here. Right? Fine. So this is fine. So you can see how we can create files very easily. Okay, fine. Now the next option which we are going to explore is, instead of X, since our focus is on reading of the file, we are going to put R. R stands for read. Okay. So now what I am going to do, we are going to open the file one more time, but this time we are going to open it in read mode, so that we can read the content of the file. And if file does not exist, then error will be raised. Okay, so now we know that we have already created this particular file, and if I execute this, then there won't be any error, right? So we have opened this particular file in read mode. Okay, now I am interested in actually getting the content which is present in this particular file. So I will take one more variable and I will call this particular method, which is read. F.read will give me whatever is present inside this particular file, and then it will be stored in text variable. Okay, so let me just execute this, and now if I print this particular text, then you will be able to see the exact same content we have got, which was there earlier, right? And then my work has been done, so I will just close it. So maybe what I can do, let me just create a copy of this also, so that you can also do this with me simultaneously. So just a second, the copy has been generated. I am sharing it with you so that you can kind of try this. Okay, and it has markups also, right? So you will understand what I am talking about, right? So before each cell, right, I will try to give provide some kind of insights what we are going to do, right? So this was before X, this was before R. Okay, fine. And then next we are going to talk about how we can kind of read some portion of the file, right? So that will come next. Anyways, let me just try to share this with you. So again, what I recommend, ensure that you create copy of this and then use that particular copy for modification. Otherwise, the same version is kind of shared with all of you. So if you modify in the shared version, then the original version will be kind of destroyed. Okay? Okay, so this particular link is for file handling, right? And particularly I am referring to read, right? How we can read files. Okay, so let me just close this because you can play with it. Okay, so this is what we have done. One question is there, how we can delete it, right? So here you can see there is one option of delete file also, so we can directly delete it from over here. And also when you kind of go out of this particular environment or system, then automatically all the files which you have kind of created, they will be kind of gone, right? Deleted. So you have to kind of keep copy of it. Okay, fine. Anyways. But most of the times what will happen when you work with respect to some kind of standard data set like MNIST and all, their files are ready-made available in the internet, and you can just get those files, put it inside this folder, and then get. Of course, these things will become more clear when we talk about some specific data set, and I will explain in the upcoming sessions how we can take data out of them and how we can get. For example, in one of the sessions, I will be talking about kind of data set associated with Titanic, right? So Titanic data we will take and we will try to predict kind of based on the data and which passengers had traveled, right? A lot of features are available with respect to his passenger, his economic condition, his kind of whether he got first class or second class kind of setup, whether he was again gender, right? He or she, right? Depending upon that survival date was different. So all those things, based on that, we will try to design one nice machine learning model which can predict that what will happen to Titanic if it let's say what will happen to each and every passenger if can be predicted if this event happens now, right, with the help of this model, right? So that's the idea of it. But again, so what I'm trying to highlight over here is the data is in some specific format again, but it will be a file and we will get data from that particular file, and for those kind of things this is essential to know at least basics of file handling. Fine. Now let me go ahead. So read method typically returns the entire text as a default behavior, but sometimes we may need to kind of fetch only some initial characters. For example, if I write 5 over here, then what it will do? It will just return first 5 okay. So again, I am reading this again and again, so therefore you may it may give some kind of different answer. But for the very first time, what it's going to do, it will read first 5 kind of characters for sure. Okay, so maybe I can open this one more time and then let me run this. So then you can see it's going to return the first 5 characters of the file. Right? So that's how it works. Again, I can open this instead of RT. T stands for text, right? So I can just open it in R mode also. Then also I will get the same answer, right? As you can see. Right? For some kind of files, we can go ahead with RB option also. So if I, it's going to consider the kind of byte way, right? But it's not that useful. This is just for sake of completion that there is one more option. RB is also there. Okay. Now the most important, I should say, or interesting part comes where we are going to do something interesting, right? So let me kind of take these quotes, right? So they are anyway present in the output. But what I'm going to do, I'm going to create one particular file, which is nothing but quotes.txt, and then I will read it line by line. Okay, so let me do this. What I'm going to do, I can just right click over here. Okay, maybe so I will just right click over here and I will just new file. I will just say it's quotes. Okay, quotes.txt. Okay, I have to ensure that name is correct. Okay, fine. Just fine quotes.txt, and then I will just write some quotes over here. Okay, and now, so now imagine that this kind of file is given to you. Okay, so let me just kind of open it one more time, so you can see that each line contains some code. Okay, so maybe I can just close this because this is not required, and now you can see that this is my file. Okay, so let's say this kind of data is given to you in terms of file. What is the task which is given to you? You need to open this particular file and then read the content line by line and put it inside a list. I'm repeating one more time. You have to open this particular file in read mode. It's a text file, txt file. Someone has created like this in the notepad and send it to you. So what is your task? You have to open this first. You have to read it one by one, but you don't need to do this literally. You are going to write a code for it. Okay? We are going to read it one line by line, and then, so let me close this. We don't know what is inside this. Okay, so let me close it. Okay, and then what we'll do, we'll create one list, and that list will contain line by line content of this particular file which we have read. Right, so those things we are going to do. So let me try to focus. Let me kind of create slideshow mode so that you can see like what we are doing. So as you can see, initially I am just giving the path of the file. So since I haven't created any subfolder, so I can just give this name quotes.txt, and by default it will pick it up. Okay, so I have opened it in read mode. Now initially this is the list which I am considering, which I am going to create, which is called quotes. Initially I haven't read anything, so therefore quotes is kind of empty. Now this is the function which is new one, which I haven't talked about yet. The function name is readLine. So what is the idea of readLine? It's going to read content of the file line by line, right? So I have taken one variable. The name of the variable is line, and in the line we are going to get content of the file. So initially, do you agree that we will get content of the very first line of this particular file? Okay. Now, whenever we have contained, right? So while line is true, so that means whenever we are not getting some kind of empty thing in line, we are going to repeat these things. Oh, and what we are repeating? First we are saying strip the line. So what we are going to do, stripping means we are going to remove the unwanted white space which are appearing either in the beginning or towards the end of our text. So that's the purpose of strip. Whatever white space or extra space is given towards the end of the string or end of the line, we are going to remove them. Afterwards, we are going to append. Append means we are going to add this content in the end of the list. So initially list is empty. So do you agree the very first line, content of the very first line will go to the as a very first member of this particular empty list. And then we will continue this method. Now we are going to read line, we will call this particular read line function one more time. So now we will read the second line and then this loop will continue, right? Again we will go to this particular line variable. It's true because second line is also present. So we'll repeat the process, we'll strip it, then we will append it to the list. So now content of second line will go to this particular list again, which already contains now one element. So now second content of second line will go to the as a second member of this particular list, so on and so forth. And afterwards we are going to close this particular file, and then we are also going to print content of this particular file so that we can understand what we got. Right? So let me try to run this and let's see whether we get the same thing which are present in the file or not. Okay. So as you can see, we get this 5 things, but these 5 things are appearing. They are part of this particular. You can see this printing mechanism. We are not printing something from file now. We are printing something which we have copied from file to a list. So this is nothing but we are just printing the content of this particular code. Okay. And code is nothing but it's a list. Okay. So if you are confused, then maybe I can just take this variable as list. Let's say this is my list. Okay. And then whenever it comes, I just need to change it, right? So maybe I can just type list over here, and then I have to append over here. Okay. And then I guess rest of the things are fine. Okay. What do you think? Whether this will work or not? Okay. Let's see. Okay. It reads every line irrespective of it has quotes. No, it has nothing to do with quotes. Quotes were given just to showcase that kind of what do you say? That quotes are from some famous spiritual leader. Okay, so sir, append line list. Okay, append line is equal to file.read. Okay, let me run this. Right? So in case of any error, you will help me to solve it. Let's see. Okay, so error is happening over here. Right? One more time here. Yes, thank you. So Lavanya is correct. So here instead of quote, I have to mention the new name of my list, which is nothing but list. Okay, and then this should work. Right? Hopefully. Okay, one more error is list.append.list last for loop. Okay, so maybe I have done a lot of changes. That particular thing is appearing many times, so therefore here I have to kind of again change it. Right? So many times that particular thing was coming, so therefore again line number 10. It's talking about list.append is equal to list for list.append. Here it looks correct. I'm not sure what's wrong over here. The line.strip is fine, and then I'm just storing it somewhere here. I can give something else also. Right? For example, I can give L, no issues, and then L is I'm appending. As you can see, now it's working, right? So it doesn't matter. This is that quotes were given just to showcase that list contains all the quotes, but you can give any name. Like for example, here we have given name list. So now hopefully it's clear that we are talking about list, and we are just pasting all the elements which are present in the list. Okay, and it doesn't matter, right? Or content can be anything, right? This is just to showcase that if you notice carefully, then all this are nothing but quotes from Swami Vivekananda, right? So therefore, right, in some sense, I've written like this. But in the next example, it will become even clear that not necessary that quotes are required. It's going to read everything, whatever it comes. Okay, fine. So now, very interesting example we are going to do. Okay, the example is like this. First, let me just talk about the task, and then I will showcase the code, of course, and then we will create one file and then do this particular task. Let's say I give you some marks. Each line of my file contains some marks, and I don't know how many students I'm going to consider. And what you need to do, you need to figure it out from the file itself, that how many students are there, what are their marks, and what is the average of this. Okay, so this is the task. Okay. So let me kind of do this. Let me first create one file like this so that you can appreciate this, and then we'll talk about this more. Okay, so let me just a second. Let me just create one new file. This time I'm going to call it third.txt, because actually we are talking about third file which we have created. And now let me double click so that I can modify this file. And now I'm going to randomly give some kind of marks. Let's say out of 100 itself, but some marks. Let's say 45, then 78, then 65, right? Then 79, then let's say 83 or 82, whatever. Then 94, then let's say 39, then let's say 60 itself. Okay, let's say, and then again, let me quickly give you some kind of numbers. It doesn't make much difference. It's just to showcase functionality, how nicely you can kind of process some kind of arithmetic operations on this kind of file with the help of this setup. So this is my file, right? It's a very, I have given this kind of 16 numbers, and effectively what I want, I would like to kind of, maybe I can close this so that you can see this properly. So this is my data. I have stored this data in this particular normal text file. Let me close this, okay? And if I open it one more time, then it should appear. Right? So okay, fine. So data is correct. Okay? File is correct now. So now what I am going to do is I want a mechanism which can find out average of these numbers. And I know that 16 numbers are there, but this Google Colab does not know, right? Google Colab does not know that what is the content of the file. Okay. So what we are going to do now is what variables do we need if we want to solve this particular problem. We want total of all the marks. And along with that, we would also like to know how many students are there, right? So based on this too, we can find out the answer. So as you can see, total is equal to 0, count is equal to 0. Total is corresponding to total of marks, and count is corresponding to how many different participants or students we have considered. Okay? So, and the approach is very much similar. First, I'm going to, with the help of readline, I will get content of the very first line. Now, something else I'm doing, apart from stripping, I'm also converting number into a float, because I don't know, some marks can be in float also. Then I'm just adding the marks into the total, and with each addition I've also increased the value of count. Fine, and then I will repeat this particular process. So whenever I reach to the end of the file, at that time value of line becomes empty, and then I will come out of this particular loop. So at that time, whatever the value of total is, that will be the total of all the marks. And I will also have count of all the numbers, means count of all the students. And then basically what I need to do, I just need to find out average, which is nothing but total divided by count, and then finally I will close this. Okay. So let me just do this. So average is 48.75, and if you actually take this file and consider all the numbers, then you will get the same answer, right? You can do this manually also. The answer will be 48.75. Now couple of questions are there. So let me try to answer them. So what will happen if you don't put, let's say, if you don't do this strip? So let me try this. Okay. So now this is without any kind of stripping. Let's see. It's working in this particular case. But it's good practice to do this stripping, because many times it may not work if my data is like this. Let me try to showcase. Right? For example, in the first case, if I have this kind of thing, okay, 45 is appearing somewhere in middle, right? So then in some cases, right, this code, okay, so in this particular case it's working, it's good, but many times it may not work, right? So it's a good practice to use it, but if it works without even it, you can avoid it, right? It's up to you. Fine. So it's not a big thing. The main idea, the core idea of this particular entire work is this, that we have initialized these two variables. We have incremented them with the help of readline, right? Readline is the main function because it will help us not only to give content of every line, but this will also in some sense help us in getting the exact count of how many lines we are reading, right? So both ways it's helping us. And finally, like, so we don't need to verify this answer because we know that this is the correct way of finding average. Total divided by count, that's correct. So if provided value of total and count are correct, our answer is correct. Okay. So that's how it works. And finally, so this is kind of very interesting. Now you can think of any kind of arithmetic operation because you know Python operators. So you can do a lot of things with given file. Right? For example, I can give you a small task to find out maximum out of given numbers in the file, right? You should be able to do it very easily. Fine. So this is all about read function. Now similar to read, we also have kind of a Python write function. So now let me corrected file. So actually there was no error in this particular file. That the error came because we changed the name of the list, and that's it. Otherwise, everything is correct in the original version itself. So you can go ahead with it. No issues with it. You may get some kind of error. For example, okay. So you tell me when you will get error. For example, you try to run this particular code. Okay. This is telling kind of Python interpreter to create a new file. But file is already existing, and if you try to create it, then of course you will get an error. Right? So for example, in my case, you can see first.txt exists. If I try to run this one more time, then of course error will come. Right? So that doesn't mean that my code is wrong. That means my understanding is missing, right? So understanding is this, that if file is already existing, and if I try to create it one more time, then of course error will come. So maybe you are getting this kind of error, but otherwise the entire notebook is correct, no issues with it. But of course you have to do some kind of work, right? I haven't given you the content of, you can come up with your own content. For example, with respect to quotes, I haven't given you this quotes, right? If you want, I can just give it, but it doesn't matter, means you can write anything, right? Just write something in line number 1, line number 2. But if you want, I can also provide the content of second file, which is nothing but quotes.txt. So let me just give it in the chat box if you want to kind of regenerate whatever we have discussed. You can just copy paste this in the quotes.txt. But hopefully you understand this is independent of what we are writing in those files. Of course, we can also create copies of those files, but those things are not required usually because as you can see, and soon you will be able to appreciate, all this pain is to do some kind of task with respect to machine learning and deep learning. And for those tasks, whatever data is given to us, that will remain static. For example, if I am taking some data set like hand-written digits, so that data set won't change over the period of time. So my interest will be how can I read that particular file. That's it. I won't be needed to like those kind of things won't be needed. How to create copy and all. And anyways, there are some options over here. You can see that if you want to do those kind of things, it's very easy. You can download this also. For example, I can download this file, and then additionally, I know how to copy a file, so I can do it. Right? Of course, Python has those functions also, but they are not of primary focus, I should say. Okay, fine. So now let's focus on second part of this particular, I should say, file handling. Now we will talk about how to write file, how to write inside the files without opening them, of course. Okay, without opening them physically, of course. So in the previous explanation, I have modified those files, like I have written something inside third.txt, but that was by opening it. Right? But now we will see how we can do it without manually opening the corresponding files. Okay, so let me quickly share this notebook also, so that you can kind of run the code along with me if you want. And soon you will be able to connect the dots. So far, whatever you know, right, soon you will see nice applications of all those learning. Okay, so this is about right, file writing, I should say. Fine. So now the very first idea is you are going to open. It's okay, means you can run this. You can do this afterwards also, because file is with you. So oh, if you don't understand anything, you can ask. But anyways, I have shared this files with you, so you can do this afterwards also, right? So nothing to worry about it. The understanding part is important, and of course this won't take much time, right? Once you have this notebook, then to if you want to play with it, then it won't take much time if you understand how it works, right? So don't worry. Fine. So hopefully, can anyone tell me how the first line will go? I have written like this: file open example1.txt, and I am trying to open this in write mode. What will happen? Hopefully, I have shared the copy with you, not the original one. Otherwise, then you will modify this. Let me see. Did function. Okay, so let me see. If this is shared, then I will create copy very soon. Okay, oh, unfortunately, I have shared this version itself. Okay, so let me quickly create a copy. Otherwise, I won't be able to kind of get the original version. Okay, so it will create and write the content in the file if not existing, else overwrite it. Okay. So basically, W mode is for creation. So the answer is correct. If file does not exist, then it will create it, right? So basically, this example1.txt will be created, and if it already exists, then basically we are going to it will overwrite the content, whatever we are going to do. So basically, what will happen? Let me just try to showcase this in my files. Okay, so let me just it's connecting. You will see there won't be any file with name example1.txt. Now let me run this. What will happen? First, example1.txt will be created. We are opening it in write mode. Then we are writing hello, word inside that particular file, and then we are closing it. So let me run this. Okay. Now you will see that example1.txt has been created over here. Now if I double click, then you will see this content over here. Hello, word. So it's very easy. You can see. Just like read, we have write function. The syntax, only difference is instead of R, you need to write W. Okay. Now what I am going to do, I will open that particular file and read the content. Instead of this, I could write something else. Right? Hello, it's 4:50, or I can just say good evening, right? Whatever. Okay. So now, if I execute this one more time, then content of file will be changed, and I can verify it is changed by executing this read function. Right? So you can see that this write and read go side by side. You can write something, and if you want to verify, you can use read. Okay. Now, most interestingly, just like read lines, we also have write lines, and you can imagine what write lines will do. It will change the content of the file line by line. So you can create one list, and let's say the name of the list itself is lines. And what I'm going to do, I'm going to put each element which I would like to put in the line. Let's say element at index I will be kind of put at row number I inside the file. Right? So that functionality I want, and let's assume that row number in file is starting from 0, right? Okay. So what we are going to do, let's say I have created this new file, all right, and the mode is append mode, right? And initially, this I can go ahead with write mode also. I will explain about append mode afterwards. So let's say there is no example9.txt. So basically, this file will be created, example9.txt. It will open in write mode, and then I am going to call this particular write lines, and I am passing this particular list inside this particular function, right? And this list contains 3 lines, line 1, line 2, line 3, and there is /n. /n is new line character. So once the content or the idea of line 1 is completed, we'll go to the next line, right? That's how it works. So let me just execute this, and you can guess what will happen. We'll get one new file, example9.txt, and it will contain 3 lines, and content of line number 1 will be line 1, content of line number 2 will be line 2, and content of line 3 will be nothing but line 2. Let me just execute this, and now if I showcase, then you can see this example9.txt has been created, line 1, line 2, line 3. Okay. Now let me try to modify the content, right? For example, instead of this, I can write like this: A, B, C, whatever, right? A, B, C. And now you can guess what will happen. The content of line number 1 will be nothing but A, content of line number 2 will be B, content of line number 3 will be nothing but C. Let's verify this very quickly. You can see A, B, C, right? So literally you can write anything inside the list, and it will be converted into kind of copied inside the files, right? But only thing which you kind of consider over here, you can see that instead of these are strings, so I have written like this. You can also try like this. For example, let's say 23, 54, and let's say 16. Let's see what will happen if I give numbers like this. Okay. Okay. So then some kind of error is coming, because as you can see, arguments must be of form string, right? So that means you can't go ahead with it. Okay. Okay. So let me repeat one more time what I was told, that whatever you are going to provide over here, they will come line by line, right? So for example, if I write like this, 23 inside this string, 54 inside this string, okay, double quotes, I can just write like this, and then let me put double quotes and some other number, let's say 3, okay, and let me run this, okay, and let me showcase what, how and what we got. So you can see what are the issue over here. If I don't give /n, then what will happen? All the everything will be treated as one kind of entire string, right? So we don't want this. So what modification we have to do? We have to put /n once the content of first row has been kind of completed. /n, right? And now if I run this, then first row will contain 23, second row will contain 54, and third row contains 3. So this is how it works, right? So you have to remember that whatever you give inside this write lines function, it must be of string format, right? So if you are passing list, the list must contain strings. You can't give some kind of numeric values to it directly. And for proper kind of, one can say, formatting, ensure that you put /n after completion of content of every line, right? So then it will work properly. Okay. Now let me try to showcase what will happen if I write append over here. So what's the idea of append? You are going to append means you are going to add something towards the end of the segment. So if I click this, then let me just showcase what the changes in example 9.txt. You can see the same three numbers are appearing after the first three numbers, right? So if I kind of run this one more time, then what will happen? The same three numbers will appear twice. Okay. So if you go over here, then basically we are just appending whatever the content of the file is there. We are appending with these three numbers again and again. So that is E mode, right? So that this is different from W mode. W mode will write the file just one. Append mode will write the file as many times we call it, right? So that's the difference. So you have to be careful whenever you are using append, that your file will be modified per execution. Right? Whereas in the case of W, once it's written, it won't be changed. Right? Irrespective of how many times I'm going to execute, right? It's going to give me the same output in terms of file. Right? So as you can see, this is my output. Okay, fine. Of course, you can verify, right? What is here? Basically, you don't need to create example 9.txt. By default, this line which I have highlighted, it will create example 9.txt because W is the mode. So in W mode, what will happen? File will be created automatically if it does not exist. Right? So you don't need to worry. Right? Fine. Okay. Now there is one more interesting kind of function which is called seek function. Let me try to. Can we append new integer at the end of? Yes, you can append new integer after the very last element. Right? You can go ahead with A mode and then whatever elements are there in the list, they will be appended after that particular last element. So /n is just to denote that we are inserting something after that particular line. For example, if I remove this /n, then let's see what will happen. Then the cursor will be on third line, not on the fourth line. If you notice carefully, right? You can see that whatever is going to be executed, that will be added. It will be after 3 only. But if I write /n and then execute this one more time, then you will be able to see one new line number 4 over here. That is for sure. So if you see this, then you can see one more line. That's the impact of /n. So it's up to you where do you want to insert something. Just after completion of the very last line of the file, or do you want to create one new line? Okay? So it's up to you, and then add. Fine. Okay. So seek function. Let's try to understand this seek function. So basically, let me just create this. Okay. So example 3 is there. Let me just see what it gives for now. So you can see modified file. That's the content of this particular kind of, I should say, file. I can just okay. Let me just try to zoom out so that you can see this. Okay. So basically, what we want to do, we want to change the kind of current file position within the file. So in simple words, what we are trying to do is, we would like to include something, or we would like to modify the existing file, but we don't want to modify it from let's say location 0. We would like to skip some initial characters, and then we would like to change the file, right? So for example, it's better that instead of this, let me open this in write mode, and let's see what will happen when I execute this. Okay, so this is completed, and let's see the outcome of this. So you can see now, lot of nulls are coming, and then finally you can see modified file. Right? So basically it's like we are skipping some characters, and then we would like to kind of modify the file afterwards. Right? So that's the whole idea of it. Right? You can again get the same content with the help of this read option also. So as you can see, kind of 500 blank characters, and then we are getting this modified file. So if you want to skip some of the portion of the file, then you can go ahead with this seek option. Okay. But now the issue is we don't know where we are and how much we need to kind of skip, right? That number sometimes we can't judge. So for that particular purpose, Python is functionality of tell also. So with the help of tell, we will know that where we are as of now, and then we can change it, right? So for example, we can open this particular file in read mode. Let's say example 10.txt. We are writing hi. So once you write something, do you agree that file pointer location will change? So hi contains exactly 2 letters. Okay. So now 2 characters have been kind of determined. And now if you ask what is the location, if you ask to tell function, then it will tell us that it's 2. Right? So it's very kind of intuitive. Let me run this one more time. So instead of hi, let me just write something else. Like instead of hi, let me write MNIP. And now let me run this. So now it's telling me it's going to kind of insert from location 4 onwards. And again, locations are starting from 0 onwards. So therefore it looks like this. For example, if I write like this, then it will give me 1. Right? So that's how tell function works. And so basically tell and kind of one can say seek, they go side by side. With the help of seek, we can skip something, but in order to skip something, we must know where we are. So for that particular purpose, tell function is there, right? So that's how they work. And lastly, we are going to use this append mode to include something, to write something towards the end of the file. And what we are going to write? We are going to write just end of the file. So that's what we have written over here. So now let's see. Let's go to this example. It's example 10. So it's over here. Let me double click. So as you can see, end of the file. And that is happening just after M, because initially I had done just M. That's why. Okay, fine. Okay, so now one more query is cal is similar to length of the function. In some sense, it's about length of your file, right? How many characters you have so far in your file, and what is the next location which is kind of being filled if you go for the writing of the file function. Right? So basically, it's going to tell you the location where the new content will be put. Right? So that's the idea of tell function. In some sense, it's length, but it's not length of a function. It's length of the content which you have inside your file. Right? So hopefully you understood the core aspects of file handling. So I'm here for the next 5 minutes. So in case of any queries, you can write in the chat box. I will answer them, and we'll break for 5 minutes, and then we'll continue for the next session. Thank you. And I've shared both all the 3 notebooks with you, so you can practice. And in case of any queries, you can later on contact me. Thank you.
वो लगा दो बिना ब्रेक हो ना पॉज करो मेरी रिकॉर्डिंग पॉज Okay, good afternoon to everyone. It is audible. Okay, so now we have been discuss with you about the file handling, right? How the file should be created using the Python, so that whatever the data which are going to be given to the program, that may take from the file, and whatever the output your program is going to generate, that should be stored permanently into a file. Okay, so for that purpose we are required various file handling operations which are provided by Python, and hope you understood the concept which was discussed. Fine. So now I am going to be talk about again little bit about the function, and then I am going to discuss about another important concept, that is modules, package and library. So how we can create our module, what do you mean by module, what do you mean by package, what do you mean by library. So these things we are going to discuss. So one key point which I want to emphasize about the function is regarding the parameter passing. So we have different way by which parameter can be given to the function. So now you can observe here in the function, we can give the argument to the function by using the keyword argument or with the variable length argument, or maybe the default argument. And it is necessary that whenever your function is supposed to take some argument, in that case that argument should be need to be assigned when that functions are going to be called. So during that calling of the function, we are required to give the parameter. So such parameter which we are giving to the function during the calling of a function is known as the actual parameter, whereas the parameter which we are defining during the creation or declaration of the function, those arguments are known as the formal parameter. Okay, so required arguments are such arguments which are necessary to be given to a function. For example, if you want to create a function int, and we are writing this is the def sum, and we are giving some parameter a and b, and going to be return a plus b. So sum is going to return. If you want to call this sum function in the calling program, so we are supposed to call that function by writing the name of the function, and since it is returning, so we can take some left hand parameter, that is L value x to the assignment, and giving some values, say 30 and 40. So here this is the necessary to give all the relevant number of argument to this particular function. If we will miss any argument which is not going to become equal to the total number of arguments which are required into this calling function, then we will get an error. This is also one point we have to note down, that whatever the argument we are giving here in this function, that is basically one kind of positional argument we are giving, meaning that the first position, it means the first value which are giving or the variable which are giving, that will be associated with the first argument within the function definition. Second will be with respect to the second argument in the defined function. So this is the positional argument which we are required to give, and they are given to that particular variable. If we are going to call that sum as a 40 minus 30, it means that to this A, 40 would be assigned, for B minus 30 should be assigned. So this position matter. In case we are going to give the less number of argument, in that case we will get a appropriate error that I will demonstrate with a small example. Second is going to come as a keyword argument. Okay, so when we are going to give these arguments as a 30 or 40 suppose, then we does not know whether this 30 is for B or for A. So that association are going to be based on the position. It means first will be always going to be referred to the first argument, second should be assigned to the second argument which has been declared in the function definition. But if this order is going to be changed, they are going to be assigned 40 to A and 30 to B. So we are required to careful about the position of the variable which we are taking during the definition of the function, and in that order we have to give during the call of the function. If we does not want to worry about these position, then we can give the argument by name. In that case we should call the sum like sum, here you can take y, and give some name to that argument. So what name we are giving? A equal to say minus 30, comma B equal to 40. Although if you want to make it to be B equal to minus 30, A equal to 40, so they are going to be considered to be in the appropriate order. So order or position we does not require to remember while we are going to be do the calling of the function. Other way of making the parameter passing was the variable length of the argument. Might be possible that we does not know how many number of argument we are going to be required to be passed at a particular call of the function. So in that case we can give more than many number of argument within the function definition, and from that argument whatever the different values or argument parameter which you are interested, we can use and process in our program. Other is going to become a default argument. In case we are not going to be give any parameter, and in the definition we have been declared that argument as a default, in that case the program will not give the error, but it will take by default those argument as a parameter value which are given to the called function. Okay, so let us take example of this one and just check what is happening. So we are taking this one of the multiply function, declaring one of the multiply function where we are giving a definition multiply number, maybe multiply say 3 number. One function we made multiply 3 numbers, and we are giving here maybe random number say z. Okay, and we want to multiply that one. So multiply x into y into z, and then we are displaying the result of this multiplication. Here we are not getting back some argument once the function are going to be executed. Now if you want to call this one, there are 3 ways. One is that I am taking also some argument here as 1. Now if you want to call this function we are required to here there is a error. What error is coming? While scanning string literal, so syntax error is there. It means that here we does not specify the code in the port the string. Now it is going to become work, but here name x is not defined. Okay, we are taking the small x and small y. Okay. So this way our interpreter will going to be give us various kind of field. Through that we can able to check at those error statement which are coming, and accordingly we can able to make our program to be corrected. Now check here. In this case, if I am going to call this multiply three numbers, and it is not necessary that we should give the argument. If we are not giving the argument, in that case, still that multiply three number functions are going to work perfectly. Okay. And if you want to give some value, we can also give here for another way. And suppose we want to give for here we are using the one option to give the value is, suppose we are giving the 10, 20, 2. Okay, so we are given these three parameters. Multiply three number. Okay. Still we can get the outcome and the function working. In this case, we can try different variations. Variations in the sense that we can able to take this multiply three number, and suppose we want to give only last parameter. In that case, I can use the keyword argument. So z equal to say 1, say 10. Now this will also going to work. Or if you want to give, now here suppose I am giving the some argument, say I am given the 4 and comma z10. So how many argument this multiply three number required? This will be required at least 3 argument. But what we are doing, we are giving one argument which does not used as a keyword argument. So this interpreter could not able to associate that code should be given to whom, to x or y. So this will create one kind of confusion. But what it does here, what it is doing here basically, let us take this 1 and take this to be as a 2. What is happening here? If you are going to closely look at this one, it is taking 1 and taking 2 as a z and taking y to be as a 8. So this is coming 16. If we are giving the less number of argument, in that case what will happen, that first argument, because it is now it will consider as a additional argument. So first argument which we are giving, that will be taken to the first argument x, and second we does not specify anything, so they will assume the second to be as a default value 8, and the third we are giving by z equal to 2. It means we are giving that z should be assigned the value of 2 as a keyword argument. So this will going to be considered this z as a 2. But if suppose we are going to be not giving this y to be as a default, then let's see what is happening. Now we are getting the error, because now in this case y need to be a second parameter, and that we have to give in the calling of the function, and that is required to be mandatory to give this value, otherwise this will not going to be assigned to the y. So these kind of variations we have to remember, when to give the with argument, when give without the keyword argument. Okay, so that we are required to be remember. Now another important point we have to note about the keyword argument. If suppose we are going to give here first argument as z1 and z equal to 2, and here we are giving say 5. Now let's see what is happening. What we are getting. First argument will take as a positional. Second, they are given for the z to 2 and 5. It does not going to associate with that position because z is already taken as a default argument. If we are going to give other variations of this one, let us check which variations are going to work. X equal to 1. Will that work? That is also not going to work. Okay? That is also not going to work. But if we can give here 10 and then we are giving the z equal to 5, then this is going to work. Z equal to this is not working. But when we are going to give this as a first two as a positional argument, and we can give second as a positional argument, third we can give as a keyword, then they are going to work. So whenever they are going to become keyword, it means that let's change this and look in other than default. Let us check it as a keyword. So what we can do? 7. Yes, that will work. X given to be 7, y and zy, that will work. It means I can give only two arguments, third they are going to take as a default. So now here suppose it is a normal function you written, and then we are going to give here as a set 3. We are executing. Now it is working. Now here if you want to give this as a positional, keyword argument. So let us check here. We are giving x to be 1. This will be 2, 5. It will work. It will go to. It is not working. Now what we are going to take the second one? Second possibility, if we are going to take y to be also as a 2, the number is need to be y. Some error here. It is supposed to work, but now you can see they are asking for positional argument. So here we are required to remember that we can able to give the values in the first the keyword, then first we have to give either we have to give as a keyword, then we can give the positional, or we can give as a positional then keyword. So when we are going to give this as a positional and then keyword, it is working. Okay, or we can give all as a keyword. So first we have to give the positional, then as a keyword. But if we are going to take any combination other than this sequence, so what we are getting? We are going to get a error. It means if we are going to combine the keyword and positional argument, so first we are required to give the positional, then you can give only the keyword. Okay? Keyword argument. Otherwise this will going to give you the error. Now you can make it to be as a, say this is given as a 1, comma, y equal to 2, z equal to 5. Now you can check. It is working. Okay. So first positional, then you can start keyword. But intermixing of the positional and keyword, that will not work, or we can give all to be as a positional, or all we can give as a keyword. So that we have to remember that. Now another was that is variable length argument. Previous class it was session it was not work due to some error. Now here we can check it. Okay. Now you can check it. What we are giving here, we are giving one of the function we are creating. Okay. Make this function to be commented. Check only one function and pf5. Okay. So we are giving the definition my function, and if you want to give it as a variable length argument, then we can able to write a star against one of the variable. And here we are using a sum. Sum is a function. That sum will going to be take all the values into this argument variable, which is a multiple values. That is going to be calculate the sum. So here sum is going to become one of the inbuilt function, which will do the summation of parameters which are given as the argument, and then these are going to be returned to us. So now here once we are going to call it, we are giving print my function, and into this function we have to give more than one argument because it is given as a star. Okay, star say that it can take a multiple argument. Now we are getting a 4, 3, 2, 1, 10. If we are not giving here as a, in that case what, if we are not giving the argument or define not the argument as a variable length argument, then you get a error. What error we are getting? Type error. My function take one positional argument but 4 were given. It says that in this case my function argument is going to be a single variable. It is one variable, and here we are supposed to give a single value, but we are giving multiple value. Multiple value we are giving here. So this will going to give you the error that my function has the number of argument which we are giving is not matching with the number of argument which are desired into the my function. So that we can able to make it to be available as an argument. Now here if you want, we can also take various argument and do this the operation with these arguments. Suppose in this case we want to just display only print. What we want to make, because see whatever the multiple argument we are giving, these are going to be taken as a positional argument. So first is known as the first argument, 2 is the second, 3 is the third, 4 is the fourth. So we are going to be display the first, let us do one thing, we can return it the summation of only second and fourth argument. So we can make return, and we are doing the summation of which argument? Argument second and plus the fourth one. It means 3 third index. Now you can run it. What we are getting? Only the second and fourth are going to be added. So this way we can able to give variable number of argument irrespective of how many arguments you want to use into your program, and we will not get any error. Okay? So that is the benefit of variable length argument. See the difference between the default and keyword argument, as I told you that in case it is a default argument. Let us take this example again. Look at the same example. Now we have been given a x, y and z. 3 parameters we are taking and doing the multiplication. If we want to call this function, in that case we have to use the name of function and give 3 arguments. Fine. So now we are getting some output to be generated. Some output came. But assume that the same function I am going to be called again and we are missing the third argument. Okay, third argument we are missing. Okay. So what will happen here? We are getting the error because the third parameter we are not giving. So in case any parameter we are not giving, so we will get an error and my function will not perform. In case this z I am not providing, I should make here to be a default type of argument. How we are giving the default type of argument? In the definition of function, we should assign some value. Say, we assign the value as a say 4. So it says that z is going to become an argument of type default, meaning that if we are not going to give the third argument, it means at the position third we are not giving any argument, still my program will going to be work and assume that z should be by default 4 if some value are not given. So now run here, now we are getting 30. So in first case we are giving all three values. In that case z will be assumed to be 3 and using the 1, 10 and 3 the operation are going to be performed. If we are not giving the third argument, in that case it will going to be assumed that z will be 4, y will be 10, x will be 1, and in that assumption the computations are going to be take place. So this is the difference between the default and argument and keyword argument. Fine. So this way we can want to use these functions, and we are required to remember that as per our requirement we should always try to define and create a function which should always take some value, which can take some argument and going to be return you back some argument. Even though if you want you can also able to pass any parameter. Say here what we given, we are giving some x, y, z individual argument. This argument can be a list, it can be a list, or it can be tuple, or it can be dictionary. So whatever argument you want, you can able to give here as a value. So for example, def sum, and we are taking here we are taking one value L. Okay. And now this we are trying to make it for I in L, and going to do some s equal to, we want to perform the summation. So we should take in this sum initialization to be 0, and then we can make s plus L I with the index we are going to access. Okay. And then we can able to come out of this one and return yes. We can call this function by giving some list 1, 2, 3, 4, and then we can call this sum and store in the result R sum, and we are giving this x as the argument, and then we can able to print R. Let's check whether it is work or not. It will work or not. We are getting some error. This is giving some error with the index or a list index out of range. Might be there should be some indexing. Okay. Okay. The problem, what is the problem here? Anyone can object? What is the problem? Why this is giving the error? What is the mistake in this code? I am taking one list as a argument and wanted to find out the sum of those items within this list. It is giving index error and list index out of line. What it is coming there? Now what is for I in L? What I will get? I will get I will receive the each individual item from this list are going to be assigned to I. So what we are supposed to sum? We want to suppose to sum the content. L itself from the list individual items are going to be fetched and given to I. If you are going to run this one, we are going to be receive that. Now this list is int and list unsupported operand type. Okay, I will check it, okay, and revert you back again. Tomorrow I will discuss this code. Let me to check what is the issue is coming. Okay. So this code I will discuss again. Okay. Although some list I have been summed in yesterday's class, I will check in this code and come back to you tomorrow. The same code I will discuss it. Okay. So let us talk about another important concept because time is lacking. We are going to discuss about the modules, package and library. Fine. So what is whatever the program we have been writing, what is the extension of Python program? Where we are writing? Mostly we are writing the program using the Jupyter, Colab, maybe Visual Studio or other online compiler. There we are trying to write on their notepad our program. When we are trying to create our program, we are required to write the program in a file. The name of that file should be the extension of .py, right? .py. So we have to write a name of the program which need to be of, say we are writing a program sum prg and return .py. Py say that our program is a Python program. If we are writing the C program, they have the dot extension C. Java, they have the CPP. Okay, like that, every program have their extension, so that your compiler or interpreter should be able to identify that this is the code of a particular programming language. So we have to create one file because right now we know how to create a file. We can use a notepad or any other editor where the program should be written. Sum underscore program.py is the name of the program, and here we can write whatever code we are going to be writing. So suppose we are written a equal to int, and we are going to be take a input, and we are going to be write enter value, and then we are taking the a, and b we are taking as a 20, and then we are going to make s equal to a plus b, and we can write the print sum is, okay, and making s. Now this program need to be executed. So instead of, if you are going to use any command interface, command line interface, there we can able to use as a Python, that is the current version of the compiler, and then we have to give the sum underscore program.py, and now on that command line this code are going to be executed, and that is going to be display the output. So whatever these programs we are creating, that sometimes going to become longer in length, might be that we consist of multiple pages to make the complete program to be able to solve the problem. So modules is required. It means that when our program going to become longer, sometimes we want that this program, it means sum.py, might be required to be split into the several files. So instead of putting all the code in a single file, we can use the modules so that codes are going to be separated and arranged into the multiple files as per their functionality. Suppose we want to create one longer system program where we want to do the sorting, we want to make my program to be do also the some kind of searching, and also they want to perform the program of the calculator. So we are trying to write everything in a single file. Instead of that, we can write different file, one for calculator.py, where only the calculator related functions or code we can write, modules we can write. Other we can write the sorting program.py, which will contain the different functions program which is related to the sorting. One we can write searching .py. So because of this way of arranging our long length of code program into different files, we are able to make that our code are going to be organized in a well fashion, and it is also required to be maintained. Suppose we want to add into the calculator some new module, I can directly add here as a definition, say power of x, y, a and b. I can write here the code, and this will be added anywhere easily. Otherwise, assume that all those code are written in a single file. In that case, we have to search that calculator code where it is coming there, then we have to write at some place. So these kind of maintenance and management are going to become difficult in a single file. So module is basically a file which consists of Python statement, just like a program, or Python definitions. It means various kind of functions. So in that module is nothing but it is a file. Remember, it is a file. That file consists of the Python code. So this module can, it means the file we are saying that module. So just like calci.py is a module. So this calci.py file is a module which contains different functions such as power, or we can define here some list as a some value. Inside that we can give any definition. It can consist of classes or variable or any code which we can write using the Python syntax. So whatever this code we are writing into this file calci.py, that program is going to become executable code. If these code I am going to take and run on Jupyter, Kellogg, Colab, or maybe as an independent code, they are going to be work perfectly. So module means that file consists of runnable code, runnable program. We can make a grouping of related code into a file module that make the code to be easier to understand and use, or even though we can share those modules, those files to individual one, they can write their own functionality related to the sorting. 5-6 sorting program they can write, maybe insertion, bubble sort, quick sort, bucket sort, and in the searching.py, some other can able to write their binary search. Okay, they can write the linear search, they can write any other searching method. In the calculator.py, some other can able to write their own different calculator related function, and later on these files can be provided, and you can able to make this program to be integrated as a one single program, where all these functions or variable which we declare can be used in the executable code. Okay, so that way these modules are going to become much more helpful to manage and maintain the code. So module can also contain variable of different types. We can declare the variable in the that modules also. Okay? So remember that here module is not the function, because if you are going to be refer the module term in term of any other programming languages, so modules are generally known as the function procedure. But here in the Python, modules means it is going to become a file which consists of the Python code. Now let us see how the modules can be created. Module we can create and how that can be used. So to create a module, we are required to save the code. It means whatever the program we have written that we want to save in a file, the name of that file should have the extension of py, just like calc.py. That I have to save. Second, I can write the short code.py. Okay, we can save. So all these code are written into these files. Now these files are available with different name, and each file consists of different functions, modules, code and program. If we want to use some of the functions which are defined into the calc or some of the variable in the sorting underscore code, that we can use in any other file, in any other program. Suppose here it is written that add, here it is written the bubble sort. Okay, some definition are given for bubble sort here for this add. Now these add and bubble we want to use in some other file, because it is already created in the file, we can able to use it. For example, we are using the input, we are using the print, we are using the len, we are using the upper. So these are the various inbuilt functions we are using. Where these functions were written? These functions were written in somewhere in the system file, in the as a library into that Python interpreter compiler, and we are just going to be use that particular modules. That particular functions are variables from that modules which has been kept as a file. So same here, we want to define from our side the modules, and we want to use the different functions or the operations which are defined in the module to be used in a program. So once we have created that module in a file.py, we want to use some of the module which are created by us. So how we can use those? We are required to use the import statement. Import module 1, module 2, module n. Okay, so we have to require to use the import. If we want to use this as a module 1, and sometimes the name of this file is going to become longer, so that files can be given as a alternative name, aliasing name, by using the import, say your module as ym. So this is the aliasing we are doing. We are trying to give another name to this your module, so that wherever your modules are required, we should refer that module by short notation ym instead of writing y underscore module again and again. So we should import the module, and then we can able to use that module. So how we can able to import some of the import some of the functions. For that we are required to use the from. Okay, from name of the module. Here we are required the from. One option that we should use the import module 1, module 2, module 3. This we can give. Or other option is that we should able to import a specific attribute from a module. So we can give as a from module name import which module you want. Say name 1, name 2, name n. This means I want to call say from, okay, calc, no need to use the dot extension, calc, okay, import. What we can do? Add. Second we can do maybe subtract. Okay, it means that from this particular module, which of the functionality or function we wanted to use, that we can do using the import from module. Let us take this example. Here you can see what we are doing. We are creating one of the file square program.py. In this module, we are defining one of the function. Okay. This function consists of one of the operation which is taking some number and going to be find out the square of that number, and then that square of number is going to be returned. So square we wanted to compute for a given argument, and into this file we also declare one of the list, name is the book, list of book, and second we define one of the number list. Okay, so this was kept in one of the separate file. Now I want to write another program, say test.prg.py. Okay, in that case, in this I want to find out the square of some number, say 20. So we have to either write how to compute the square of a number 20 by writing the code, or we can use the function which are implemented in the square program.py, or suppose we want to display the name of book which are declared into the square program.py, I can directly use in the test program which was without doing the declaration. That we can do. So here what we are doing, we are required to use this module, and from this module some functions we wanted to use. So how we can use it? We are required to use the import. At the first statement which are going to come is import. So we have to do the import. What is the name of module? Square program. Remember here we are not using the .py. We are not using the .py. So just the name of modules are required. And then we can able to call import, okay, square program, that we did it like here. Now I can able to use that functions which are defined inside this one. Yeah, it can be in the same folder, it can be different folder. If it is in the different folder, we are required to give the path of that location where that should be available. That will discuss if it will be not available in the same folder. Otherwise we can keep everything in the same folder, there should not be any problem. They will take implicitly from the same folder. But this can be available in any folder, because see, there is also one issue that we will discuss after this module. Then it will be much more clear to you. Now, so I have taken the square program. Now I have to call the square, SQUARE, and giving some number, say 5. Okay, so this is supposed to return the result. So in the test program.py, we are writing here some result r equal to square 5, and I can do any kind of computation. Say print, I made the r. Okay. Now if you want to display the name of the book in the book list, I can directly go and I can able to do the what? I can able to make the print book. I can do that. Or here you can see, because this number is taking some argument. Okay. So if you want to use that, say this square we are using, right? But this square, whatever way, this is the way of calling the function. But here this square is coming from which module, that is not clear. So this way of calling the equal to square 5 will not going to work. Instead of that, here we are required to attach the name of module. What is the name of module? Square program. So we have to write a square program dot square. Let's check here. Name of module is square program dot square. It means in the square program module we are referring the square function. If we want to display the name of book, we should write the square name of module square program dot book, and then we can print. We can print. So square dot program book or square program dot num list. Remember that in the test program dot py we have not defined the square function nor we define the book list or number list. Yes, square can be happen in different files, but in that case we are required to see that to each of the modules we are calling the square. So say here square program like that it can be happening in another module. So from which of the module, from which of the file we are going to call the square, we are required to use the dot square. That need to be used here. Now we are required to write the square program again and again. So we can write the import. One thing I told you, we have to use the as clause. So what we can do? Here we can give the alternate name, alias naming. So what we can do? Import square program as sp. So wherever I am writing this square program, I should write more concise way sp dot square file, or we can write the print sp dot book. So that is the benefit of doing the renaming the module name, so that we are not required to write these things again and again. Hello. 7:30 बजे. Fine. So that way we can do. Now let us take another program we are creating, where we have the operation.py. One is the module. This is the one module we are creating. In that module, we are creating the summation, multiply, and we are calculating the area of rectangle, where we are giving the 2 arguments and returning this one. Also, we are trying to find out which one is the largest number among the 3 numbers. So we return one of the definition function. So my operation.py is consist of 3 different functions. So this my operation.py is known as the module. Similarly, if you want, I can create one module here, my operation, that I can make as another name, my calculate operation py. Here I can make one program area.py. This I can create in another file as a largest.py. So like that, multiple modules file we can able to create it. Okay. So now assume that we use the my operation.py. If it is used, so what we could do that we are going to be use that in another program test.py. In this test.py we want to import all those modules which are created, all those functions which are created into the my operation.py module. So how we can do it? Import name of module my operation, no need to use the .py extension, okay, as mq, so that every time my operation lengthy name we could not able to write it. Now I am going to call my operation which function sum. So that sum I should call using the name of module my operation dot sum, so that it will be clear that from which of the module, which of the function we are going to use it. Might be possible that across the different modules, different files, we have been created the function with the same name. So that conflict we can resolve by using the my operation name of the module with the function which we want to use it, my operation dot sum 1020, or we can able to use the alternate renamed alias name mo dot multiply we can do, or we can do the mo dot match, we can get this outcome. So this way these modules are going to be useful, which we can create in a separate file, and whenever we want to add any new module I can add in the file in the most efficient and better way. Fine. If you want to develop your own Python module, so that you can create any module, but in that case we have to check it that those modules how to be added into the Python community. So I am not aware of this one, but we are required to go to that Python community and they might be given the procedure. Through that you can able to add your own modules and library. But give me time, I am going to be explore this one, and before the end of this FDP I am going to be letting you know. But this we can do. Okay, so that's fine. So we created this module. Now sometimes it is also possible that if you are going to create these modules, I created hundreds of files. File means what? Modules. And they are available in a single folder. So again the problem of maintenance and management is difficult. So we could able to create multiple folders so that these 100 files can be kept into the multiple folders, so that we can easily manage that this folder contains 10 files related to some kind of sorting. This folder to consist of some which are related to the GUI related code. So like that again we could able to manage. So here we can create a package. Okay. So package is what? It is just like a container which we are saying the folder. So package is going to become a container that contains various functions to perform the specific task. For example, math package, if you are going to talk about, this package is a folder which consists of many functions, square, sqrt, power, and so many. So all the mathematical related functions were implemented in a module, and that was kept into the math folder, which we are saying that it is a math package. So we have to deal with the large amount of code when we are working on the larger project. In that case, writing everything in the same file, structure, in same file directory structure, that will be required to be a difficult and messy task. So we are required to separate our code, it means our module, into multiple files and keeping those related files and modules in a package. And there should be one package or many packages you can want to create. So package is simply, you can say it is a directory which is a collection of modules. Okay, so a package is hierarchical file directory structure that defines a single Python application environment which consists of multiple modules, or it can also consist of multiple sub-packages, subfolder. Within that subfolder, another many subfolders can be contained in. Okay, so let us take how we can create a package. Modules we know how to create, how to use it. We can able to also create the package. So package is basically a container, as I told you that, which are going to be store various functions related to required tasks. For example, we know we heard about various packages, NumPy, Panda, ACI Kit. Okay, so these are various kind of packages are there. And we can also know many packages which are going to use for different purpose. Matplotlib, Cburn. So these are the various packages which are containing the different modules. Okay, which are going to provide us more useful operations through the use of the functions which are defined into those packages. So how to create a package? For creating a package, suppose we want to create a package student. What it means that we are creating a folder student, that we are saying that it is a package. That folder student must consist of one of the constructor. It means this would be consist of one file. That file name is underscore init underscore dot py. Okay, this file need to be exist into the student folder. If I am creating a package, means one folder. Okay, so we are creating one folder, name is student, the name of package is student. and then this package, this folder should consist of one file dot underscore init underscore underscore init underscore underscore dot py, which is known as the constructor. Along with that, it can consist of multiple modules, say student detail, marks detail dot py, fees dot detail dot py, institute detail dot py. So this way, our this folder consists of many program, many file, many modules. But this folder should also consist of one of the file. Maybe that file need to be empty, but this must exist into your folder underscore underscore init underscore underscore dot py. So this file will tell to the interpreter, Python interpreter, that this folder is a package. For that purpose, it is required. So for a Python to consider that it is a package, not a normal folder, that directly, it means that folder must consist of one file which are named as a init.py. Okay. So this you can see if you want to create many packages. Okay. So what we can do, we are creating one folder institute. Okay. As I told you that whenever we have to create a package, that package must consist of one file. Which one that file? That is the init.py. So that need to be exist into the institute package. And within that I want to create many folder. Okay. This consists of one package institute. In that case I am creating many small folder. One is known as the student, other is the faculty, other is the hostel. Now into this different folder we are going to contain again the different module. Since it is a package, sub package, so that must also consist of init.py, and then the remaining file which are related to the faculty, that I can keep into the faculty folder which is inside the institute folder, and that faculty folder, because it is a package, so that should be consist of one file under init.py, details of faculty, course which they are taking, salary.py, family detail.py, related functionality are kept into these files. Similarly, hostel related detail are kept into the hostel package, having the hostel detail, staff detail, facility and mess detail. But it also contain one file named init underscore init underscore dot py. That is mandatory. Even though that file may not contain any statement, but you have to include that. Right? Now you can check this one. Once we have created the package, to inform Python that it is this particular directory or folder is a package, we are required to create one of the init.py file inside that particular folder. Okay. Now once we have created this one, we are required to need to follow these few steps so that those files are going to be used. First we are required to create directory. Okay. How to create a package? How to create a package? First we are required to create a directory. Give that directory one name. You can say package name. Okay. So that can be given like numpy, maybe as a you can give pandas, arrays, like that any name you can give, or maybe institute. That is one of the package given. Okay. Preferably the name which are given in such a way that by looking at the name of that particular package, we could able to understand what type of operation or functionality that particular package may consist of the relevant file. Then we can put the classes, required functions, variables, dot files within that particular package. Then we are required to create. It means different kind of classes, means class and object we'll talk about, that we can also create. We can create also the different kind of functions in the file, so that can contain multiple of files. And we should also create one of the init.py file. If we will forget to include the init.py file, okay, that case, that will not be considered to be package, it will be considered to be as a folder. Okay, and this file init.py, if this will going to become empty, it means that all the functions of the modules will be imported. Now how to import that package, because now this package will consist of the modules. In that case we have to use the import function, import modules. What we want that from a particular package folder I want to import some of the modules. It means some of the functions which were implemented in the import modules from package through the dot operator. How? Suppose we want to import the course module, right? We want to use the course module. Here you can see course modules are available in the faculty package, sub package. So how I can use this course.py module in my program? For that purpose, you should use the import name of the package. What is that package? Import. One option that import course. Course is available into the faculty. Faculty package is available into the institute. So institute.faculty.course. And in case this course module consists of CGPA calculator function, calculation function. In that case, we can import that particular module by using the institute.faculty.course CGPA _calculate. It means that dot CGPA calculate. So we are required to be say that from this particular course file, I am interested to use only CGPA _calculate. So we can import without any package prefix. How? We can use the from construct from institute.faculty import course. That is another way of importing the package. From institute.faculty, from this package and sub package import course. That is other way of importing the module from a package. And thereafter we can use how we can use a particular function which are available into the course. We are required to write the name of module dot CGPA, name of the function CGPA calculate, and then this will be calculated. So Python are going to look into the list of directory which are defined, where they are going to look for the directory. So generally this directory, or you can say the package which you are creating, that should be defined into the sys.path. So this is one of the system file in which we are required to be mention those packages which are available there, and automatically your interpreter are going to search for those packages inside that system configuration file. And if it will be not available there, keep on checking for the second one, then third one, till that system.path configuration are going to be not seen throughout the complete file. So you can see here how this package is there. So I am creating a package my project. In that my project, we are creating another package project package 1. We can create a package 2, and then this package 1 consists of various modules. .py module 1, module 2, task package 2, sub package consists of init.py module this one, module 4, and within this sub package 2 again we are creating into the task package 2 and the module, and they also consist of the init.py that mandatory to be required to be contain this particular package. Now if suppose we want to import modules which are available outside of the directory, in that case we are required to be append that particular folder or directly inside a system path configuration file. So how we can do? We can use the sys.path.append. So sys.path variable of the module of the sys. This will be consist into the module sys. They are consist of the list of all the directory in which Python are going to search for a particular module to import. Where they are going to search it? They are going to search into that particular list of directory which are mentioned into the system file. Now this importing whole of the package will not make your system to be slow. Say here we are, suppose in case of my institute I want to use all the modules, sub package and their module, then we can import only the institute, not their sub package. If you want to refer only a particular sub package, then you have to import that up to that particular sub package. That I will show you. It means the level of import we are doing from that package or modules, the functionality are going to be searched for. So let us take how we are doing this one. Say import sys. We are required to importing the sys module, and then we are appending into that one of the path. What we are doing this one. Suppose we have been created one of the folder, that is some package, sample package, right? Where I created this folder in my D directory. Inside D there should be a course directory, Python, lecture, and then sample package. So now my package will be found in the sample package, which path is given, and that path I should add into the path module, path file. So sys.path.append. So now this package has been included into this particular path file, system path file. So whenever we are going to import the particular module of a sample package, so they are going to check inside this D folder and going to search for the sample package. By that they are going to know where that modules we have to search for. And then we can able to import the modules. How? Import modules. How? As usual you can do that one. Module.function name. We can directly use the function name which are available into the particular module. As usual we are doing this import. Second option, to do the import of the module available on the outside of the directory, where we should going to be use the insert. Okay, because sys path consists of list of all directory that will be searched for the module. So there we can also do this one by adding that particular package at the first position in the file. We have this file, here many packages are listed, D, C somewhere, the path is mentioned. So what our interpreter will do, they are going to start scanning for that package, starting from the beginning till they can get that folder, and then they go there and search for that particular module. But we want that my modules or the package should be kept at the first position. Then we can use this dot insert, sys.path dot insert, and making here where I want to make in this sys.path file at the first position, at the starting position, this entry should happen. This module should be inserted. So there we can make an insert comma the path we are giving there. And then if you are going to import modules, okay, as usual we are doing there. So our interpreter are going to search which are going to found at the first position in the sys.path configuration list. So this you can see how you can create a package. So we have to create one of the folder, small package folder, and inside that, because it is a small package folder, in that we are have to create one of the empty file, init.py. In that we are putting various modules, list sum.py, calci-operation.py. Now this calci-operation.py consists of many modules, whatever we made, many functions. Then we want to use that modules from this particular sample package. So we are writing one of the program test.py, and in this program we are going to be import sys, right? And then we have been added this particular small package. Okay, this I am showing that how you can able to make. Okay, how to make your this sample package should be listed into the sys.path file, configuration file. So we should be able to call this import sys, and then you can able to run this program, this part, then automatically in the sys.path it will be appended. Okay. And thereafter, if you want, you can write the test.py, and there we can able to make this import and use of the modules to be written. And once we are going to be call the modules from the package, how we can do import calc operation. That you can do directly calc operation dot, but that will not going to be that can be accessible. So what they can do, they can go and search into this sample package, or we can make the import sample package, name of the package dot list sum. In this package we are going to be calling the module list dot sum. Now if you want to call the sum function from this list sum module, then we can use the name of that list sum dot get sum and list. Okay. If you want to use the calc operation, we can use the calc operation dot power. Power we are going to use it. Okay. So like that, these packages can be used and created. Okay. Now another important thing that we created the package because the number of files which we are creating that will going to become too many, so difficult to manage. So we have been created a small directory, and within that package we are keeping the files to be managed properly. But also it is possible that we are creating multiple folders, and that is difficult to manage. So we can also create a collection of package into one of the library. It means in another folder we are keeping the multiple packages to be collected, and that package will be consist of multiple modules. So such kind of collection of packages is known as the library. Okay, you heard about the different library in the Python perspective, machine learning or AI or data analytics. It means that library is nothing but it is a collection of related functionality of the code which will do some task without writing those functionality in your code. So whatever the reusable chunk of code is there, that can be used by importing those code into our program. So package is basically a collection of modules. Module is nothing but it is the program, okay, some .py program which consists of various variables, functions, classes, and library is going to become a collection of package, right? So we have the matplotlib, pytorch, pygame, pandas, cburn, numpy. So these are the various libraries, and their functionality we will discuss in the coming sessions. Okay. So this is the way we can able to create that. Okay. So we can check. We have the various popular packages are there who are going to provide you lot of functions such as Panda, which are going to provide the various functions related to the machine learning related functionality. NumPy, which are going to provide different kind of n-dimensional array object, where whatever the different kind of operations which we want to perform over the multi-dimensional array, that is going to be provided. ACI Py, which consists of various modules which are used for the statics analytical purpose, which have the lots of algebraic, mathematical, and signal processing related modules. And we have the matplotlib, whatever the different kind of scientific plotting which we wanted to be done in our code. So to do some kind of visual plotting of the graph maybe visual representation of the data. This visualization we can do by analyzing the data. Related to that, graph generation or visual analysis of the data, they are going to be plotted using the various modules which are available into the matplotlib library. We can create a histogram, we can create a scattered graph, we can create a pie chart. So this kind of different kind of graph plotting we can do using the matplotlib library. So whatever the operation we are doing the MATLAB, all those functionality are provided by this particular package, library package. SCI kit learn, which is going to be built on NumPy, SCI Py, Matplotlib, all these are going to be used. Various modules, packages which are going to be used for the data mining perspective. Pandas, which is going to be used for doing the data analysis. In the data analytics, we can use the different kind of operations, modules which are available in the Pandas library. Okay. So we will talk about these different libraries in the perspective of different applications where we are going to use it. Okay. Fine. Now here you can see, just take two examples, then I will just in this session. Now what we did that I will create one of the file as a sq.py. Okay. This sq.py, if I want to show you, see here in this file I created sq.py. Okay. This sq.py, if I want to show you, this consists of the same square, okay, square, function, book and list. So that I created in one of the file square.py. You can see here is sq.py. So one module I will create it. Okay, and in this module, whatever functions I created or variable or data structure created, that we want to use in another program. So I am going to be use that module to be imported by calling the import sq. The name module is sq is given, and then we are going to use the name of module sq.square file. Okay, and going to give the square of this particular number. If you want to display the list of book, print the book list sq.book. Okay, and now we are able to extract all the functionality which are defined into the square module. Or sometimes we can use sq as short name as s. Now I can write here instead of sq I can write as a s. I can write as a s. Now you can see wherever sq we are required, we are using the alternate name s. Even though if you want, we can use the name of module also. That will also going to work there. Right? Now we are going to be use another module mycalc, which I created. I can show you that mycalc is here. See, this is mycalc.py I created here, which consists of various modules of related to the sum, okay, sum, area of rectangle, multiply, maximum, even factorial I have written, okay, and I written also one module to find out the odd even number. If it is odd, display; if it is even, it can display the even number. So this module consists of many different variables, data types, as well as the different functions which are created separate in the separate file. If I am trying to write all these in a single file, such like this, we have the maybe 10 or 20 modules, 20 functions are there. So this file is going to become lengthy. So I can clear this into the multiple file as a module. Now we can able to use that one by using the import name of the module mycalc, and then I am using the mycalc dot multiply, and I can able to import the functionality of multiply which are implemented into the file mycalc dot multiply, that we can use it. There is some indentation error. The code might be there should be some indentation error is came. So this will also show you in which of the code module code it was the problem. In code this import has some problem because this mycalc.py might be in that code I changed yesterday. So might be there should be some indentation error, but that way we can able to call. Don't worry. This way we can able to import the file. Definitely I will explain tomorrow again, because day after tomorrow only the different kind of libraries packages we are going to discuss, which are going to be used for the different applications. Maybe AI ML, maybe deep learning, maybe data analytics, maybe for creating some kind of interactive web applications. Okay, or sometimes we can want to create some kind of data parsing or data validation functionality which are required in the different kind of application. So those kind of different application or usage of the Python programming we are going to discuss with the different case system. Okay. There is no limit on how many modules or library you can able to create. Okay. But how much anyone can able to create, it is obvious. So library, you can remember, it is one kind of folder which can consist of multiple packages, and package can consist of multiple package or maybe the file. So any package may consist of the normal module or maybe some sub package which further consists of various modules. Now here you can see this mycalc.math, because already I imported the mycalc. So in case of Jupyter or Colab, once we have been imported this mycalc, they are going to be binded. So later on we can able to use this mycalc module and use the appropriate function. Otherwise we are required to write here import mycalc. Then only they are going to execute the appropriate module. Okay. Similarly, we can read here as a import mycalc as MC. Okay. So now here there is some problem with the mycalc as a indentation that I am going to be resolved, and tomorrow I can rerun this code. Okay. So that way you can able to get it. Okay. And if suppose we want to use any ready-made modules from the existing package, so how we can do? We can use the from. So from math import star. Star means that all the modules, all the sub packages which are available in the math, we are going to be using. That's why math is going to become one of the ready-made package. So from math import star. It means any modules I can use it. So what it is mean? We are going to be use the pi some value defined into the math, and also we want to use the sqrt function which are available, which are going to be available into the math. Okay. So here if I am using this star, automatically they are going to be taken from the math. Otherwise we have to write the math.sqrt. Okay. So ready-made we can use with the clause of from math import star. Now here you can see the package. Okay. So this package, what I did, import sys. In the sys I have appended the place where my package was created, which was created into the D folder. And then we are going to import the operation. Operation is defined basically the sample package. In the sample package, operation and so was defined. We'll show you where that package is. In the D folder I defined. So I can able to find out in the D folder. So this is available in the D coursework Python and lecture lab. I'll show you here. See here. This is in the folder D coursework Python lecture lab. Here I created this sample package, right? And this sample package, if you want to see what it consists of, detail, this sample package. See this package what consists of. See this one. See this package, I think it will be bigger. This package consists of init, right? Init file is consists of. It does not contain any list operation. Okay, it consists of list operation. It is empty list operation, which I am going to create. Say this is consist of some class we have been created some, and also this is consist of operation having the extension py. Check here .py. So this is the py. So is some module which consists of various display function. Display the name ID. Okay. So now this package which I have created attached to the system.path file at the into that file, so that for that particular module Python interpreter are going to search for that particular module within this particular folder. Then I am importing the import operation. Import operation. Once I have appended this one sample package, after that we are not required to specify the name of package. So then import operation, import show. Now I can able to use the operation dot sum, show dot display. If I am not importing the operation, then we could not able to use these particular functions which are defined into this particular module. Now here we can say using the import operation sample package dot list operation. Although we can also able to make that one of the particular modules to be imported, not all the modules. So I can use the sample package dot into this package list operation modules are there, that we are going to use there. Or in the sample package dot show I can use show module. Okay, but in case we are written here as a import operation, so only the modules which are defined into the function which are defined into the operation, that is going to be used there. Okay, so these codes are, I will again run tomorrow to show you the outcome, so that you can feel the confidence that this package and library you can able to create that. Okay, fine. If you have any query, you can ask. Now Python and shell script both are different. See, shell script we are going to write using the scripting language which was provided by Linux environment. Okay. So both are different. Even though we can write the script using the Python language, so they have the different kind of library and modules. Through that we can able to write scripting scripting like some of the statement that can be possible there. That we can do, we can make in the Python code some of the script or some of the program which are made into the different language. They can be imported or they can be used inside the Python function or module. So that's what there is one of the modules, one of the session we have been kept here. How that is known as, I think, Pentic, one of the modules are there. There we will discuss with you how we can able to use some of the code which are made into some other languages, and that we can able to import inside the Python. Okay. That is one kind of wrapper functions are required to be made. That will discuss and included in our session. Okay, regarding this quiz, we are going to be upload this quiz around before 10 o'clock. It means you can assume sharp at 10 o'clock we are going to be announced, and you will get a time to complete this quiz till tomorrow 3 o'clock. Okay, so up to that 3 o'clock tomorrow you will get a time to make this quiz to be attempted by everyone. Okay, and after 3 o'clock I am going to be disabled to attempt the quiz. So you have the sufficient time. So take your time, go and fresh up and relax, and thereafter you can able to attempt this quiz. And this quiz does not have, yes, up to the 3 p.m. This quiz is not just to give you any kind of score. This quiz I have been plotted just to realize to the participant that how much they are gaining from this session. So I expect that whatever study you did it, thereafter you will try to attempt the quiz. And if you are going to be open from the Google other places and trying to attempt those answers correctly, you may get the 100% score. However, you could not understand where you are going to be like the concept. Okay, so first you try to do all the questions yourself, how much you have the understanding after going through the slides and different material. Okay, so just you try to see that how much you are able to grasp the concepts which are taught in these last few days. Okay, but everyone have to attempt the quiz. So I am not going to be consider that who are getting less marks, who are getting the more marks, but I want that at least, okay, sufficient number of questions definitely going to be solved by everyone. Okay, so attempt this quiz. 10 o'clock we are going to post, and by up to the 3 p.m. tomorrow this will be available. Okay, and still if you have some issue, you can just contact us via the WhatsApp group or maybe the personal message. We are going to be solve your query. Okay, so this much for the today's session. Tomorrow I will again take this view of the package library concept or some example to be scooted for you. Okay, so fine. So I am going to end this session. So good night to all of you. Thank you.